for the flight Aero Standards Workshop to Technical Excellence. We are now inviting both SAE India members and non-members to begin boarding at this time. Regular boarding will begin in approximately another 10 minutes. Stand by. Thank you. Members, good evening. Welcome on board Flight Aero Standards with service from India to technical excellence. We are currently third in line for takeoff and expected to be in the air in approximately another 5 minutes. Stay with us. Till such time, we ask that you please fasten your seat belts and secure all your SAE belongings. We'll be right there. Stay with us. Good evening, members, ladies and gentlemen. Welcome to the SAE Aero Standards Workshop. Standards play a critical role in ensuring the safety, quality, and reliability of products, processes, and services. It also ensures efficient production, cost reduction through competition, and supporting regulation. SAE standards are authorized, revised, and maintained by over 9,000 engineers and other professionals and are used by 120,000 members located around the world. SAE also serves as the administrator for USTAG Technical Advisory Group to ISO TC 20, 22, 70, 127, 195, and many more. In short, ladies and gentlemen, SAE is global standards. Did I say global? Gold standard when it comes to aerospace. The standards products of SAE International are in full use around the world today. SAE Technical Standards Development Program is now and has been for nearly a century among the organizations. Its Aerospace Standards program has made SAE the industry's most prominent standards development organization, SDO, today. The technical committees of SAE, the heart of organization's consensus standard program, have been primary in moving forward many SAE partnership, work of SAE affiliate organizations, consortia, driven standards capabilities, and more. Okay, now what are the objectives of this SAE Standards Workshop? The three objectives are to create awareness on global aerospace standardization activities of SAE International, ANSI, SAE ITC, and other standards organizations. Number two is to provide opportunity to aerospace practitioners, professionals, academia, and students on various aerospace standards committees related to various aerospace technologies. Last but not the least is to help aerospace professionals' career development by involving them in global standards development, integrate and connect Indian aerospace professionals with a global aerospace community through aerospace standards committees and other knowledge sharing activities. 2 days, 21 speakers, 2 parallel sessions, and a lot of knowledge. The major topics covered and discussed are, ladies and gentlemen, starting from additive manufacturing to advanced air mobility to aerospace actuation, couplings, aircraft system development, AI in aviation, counterfeit electronic parts, cyber physical systems, electronic transaction for aerospace, electrified propulsion, the IVHM, modeling simulation training, polymer matrix composites, standardization of UAV, unmanned aircraft propulsion, and many more. The format of this workshop is 2 days and 2 parallel tracks. And to deliver the welcome address, I'm indeed very happy to invite Ravi Shankar Mysore, who is the chair for SAE India Aerospace Forum. Ravi, since February 2021, is playing the active role of the chair of one of the important forums. For those who are not familiar with this term, forums are the group of experts, subject matter experts in a particular industry. SAE India has 4 forums. So Ravi has been associated with SAE India since 2016. He has accumulated over 32 years of industry experience in engineering and retired as VP Engineering, Global Engineering and Technology Center, Collins Aerospace. The center grew from 100 to 1,400 engineers under his leadership, with capabilities in mechanical, electrical, electronics, software, materials, reliability, and systems engineering. The center works with all the strategic business units of Collins Aerospace in the areas of product design, development, sustenance engineering, and technology development. Ravi began his career with L&T and worked for BEML, TCS, and Infosys prior to joining Goodrich and now Collins Aerospace. Ravi has a bachelor degree in mechanical engineering from NIT Surathkal and a master degree in mechanical engineering from IISc Bangalore. He was one of the founding members of NASSCOM Engineering Services Forum and served on the forum from 2005 to 2007. Over to you, Mr. Ravi Shankar Mysore, to deliver the welcome address.
Hey, thank you, Venki. Thank you for the kind introduction. Good evening, ladies and gentlemen. It gives me great pleasure to...
Ravi, I think you are on mute. Can you kindly unmute?
I'm not good. Are you able to hear me?
Yeah, I can hear you.
Are you able to hear me, Venki?
Yes.
Okay, great. Thank you so much. Okay, so welcome once again. Really gives me great pleasure to welcome you all for this Standards Workshop. As chair of SAE India Aerospace Forum, it's really a privilege for me to talk a little bit about what why we've organized this workshop and give you a little bit of background about SAE India as well. I'm sure many of you know and have been associated with SAE India or have heard about SAE India for some time now. It's a technical society which is closely associated with SAE International and serves the mobility industry with a strong presence in automotive, aerospace, and off-highway sectors. We have over 3,300 professionals from 150 industries, 50,000 students, and 1,500 faculty members from 486 collegiate clubs as members of SAE India. Over the past, several years, we've been focusing on programs for both professionals as well as students. Not only that, with a view to provide a strong focus on specific industry segments, we've established multiple forums like Venki was mentioning. We have an aerospace forum, automotive forum, and off-highway forum, and these forums work very closely with the sections of SAE India. Now, SAE India itself was established in 2009. And like I mentioned earlier, we've been conducting seminars, conferences, workshops, and professional development programs for professionals, students, and academia with a focus on aerospace. In fact, we recently concluded Aerothon 2021, a virtual aerospace design contest for students. We had over 350 students from over 50 colleges participating in this event from across India. In fact, I'm sure many of you who have logged into this workshop today had an opportunity to contribute to this event as judges in that program. We're now focusing on professionals. So now we are conducting this Aero Standards Workshop with a focus on industry professionals and academia. So why workshop on Aero Standards? I think of late the trend is to have workshops on very trending topics like AI, ML. So wherever you go, you only keep hearing workshops about artificial intelligence, machine learning, etc., 5G. But then we chose the topic of Aero Standards, and it is driven by multiple reasons, right? So I think one first fundamental reason is there is a very large community of aerospace engineers in India today. Over the last 10 years or so, the number of people working in the aerospace industry has actually grown leaps and bounds. This is, across multiple industry segments, if you will. Of course, we have, the defense research labs, HAL, NAL, ADA, who've been in India for several decades now, and they continue to contribute significantly to the aerospace activities in India. The next is the large engineering and technology centers of multiple global companies. Today, you name the company, any large aerospace company, they have a fairly large engineering and technology presence in India. Whether it is Boeing, I can go on, Boeing, Airbus, GE, Honeywell, Collins Aerospace, Thales, Moog, Safran, Bombardier, Rolls-Royce, etc. I'm not too sure if anybody is left actually in this large aerospace companies where they do not have an engineering center in India. Then the next part is we have again engineering service providers like TCS, Infosys, HCL, Wipro, Quest, Cyient, L&T, Tech Mahindra, etc., working very closely with these large aerospace companies. So the next part is the manufacturing side. Again, on the manufacturing side, there is a significant growth in the manufacturing. It's essentially driven by extremely industry-friendly offset programs, as well as the production-linked incentive schemes that the government is providing to the manufacturing sector. So what does that mean? What this means is actually now, the activities that are happening in India is just not limited to what we want for India. It's actually for the world. All these are, global companies working across, multiple geographies. So in a scenario like this, what is very important is quality. While everybody says quality is given, it is not really easy to achieve 100% quality, right? So, and aerospace standards play a significant role in achieving extremely high quality. Again, working in a global environment, communication becomes extremely important when you're communicating across geographies, across time zones, across companies, again, using a standard language, standard way of communication becomes extremely important. And not just quality, I'm sure all of you agree that, safety is extremely critical in aerospace, and interoperability is extremely important. Again, in a global environment, at least, based on my own experience, whenever work has to move from US or Europe to India, one of the things that they always worry about is, productivity. How effective, how productive are engineers here? So again, using, standards, plays an important role in improving the productivity, be it, standards in manufacturing or using standard work for design and development. It really, improves, productivity. So that's the main reason why we thought we should conduct a workshop on aerospace standards, and provide an opportunity for engineers in India to connect with the standards committees that are there around the world. So here is an opportunity for you where you will get to hear the latest developments that have been happening on various standards committees. And these standards committees, it not only helps establish standards for today, but it also helps advance new technologies. There are standards being established for technologies that are going to come up in the future as well. So with that as a motive, we started this workshop. Like Venki mentioned, there's one more reason. The contribution to standards from engineers in India today is minimal, actually. It is not at all significant. While we use standards, we're not engaged in a big way in actually developing these standards and contributing to the development of these standards. I'm sure there's a wealth of knowledge in India today, with so many engineers working across multiple products, etc., in aerospace. So we want to encourage people, engineers from India, to connect with these standards committees and see how you can get involved in developing these standards and contribute to the larger development of the aerospace community. So with that, I welcome once again. It's really heartening to note that we are conducting this workshop on the 25th year of successful operation of Sae India. I hope all of you will benefit significantly from this workshop, connect with people and enjoy the program. Thank you so much. Once again, over to you.
Thank you, Ravi. I think that was a 30,000 feet overview of the workshop. Ladies and gentlemen, we shall now move on to the keynote address. I'm indeed glad to introduce the father of Aerospace Board. Yes, it was then called a board, and the creator of the forums in Sae India, one of the many believers in the indomitable spirit of the Society Sae India, our immediate past president, Dr. Balak Bharadwaj. I now have the honor of introducing him to you, Dr. Balak Bharadwaj, former Managing Director, Boeing's Engineering and Technology Center, India. A globally recognized aerospace expert with more than 4 decades of experience, Dr. Bala holds solid academic credentials in aerospace engineering and management, BTech from IIT Madras, MS and PhD from Georgia Institute of Technology, and MBA from University of California. During his distinguished career of over 4 decades, operating both from the United States and India, Dr. Bharadwaj has excelled as a researcher, technologist, systems thinker, strategic planner, program manager, and an inspirational leader. He has held numerous leadership positions at Boeing, retiring recently as the MD of Boeing's India Engineering and Technology Center, the largest such Boeing center outside the United States. Dr. Bala was also a member of faculty of Aerospace and Mechanical Engineering at Boston University for several years and an adjunct professor at other universities in the US. Dr. Bharadwaj has been an active member of the broader technical community for many years and has contributed to the American Institute of Aeronautics and Astronautics, AIAA, NASCOM, SAE International, and SAE India. He established the aerospace segment within SAE India in 2009 and has brought together various industry leaders in India to strengthen aerospace activities in SAE India. He was president of SAE India during 2018 to 2020 and currently an advisor to the managing committee and chairman of the building committee. Dr. Bala has been recognized with several prestigious awards for his many contributions over the years. Notable ones include Team Excellence Award and Group Achievement Award from NASA, Quality Hero, Process Management Role Model, CEO Recognition, and Chairman Safety Award from the Boeing Company. Awards and recognition from a broad array of organizations such as Sigma Psi, Scientific Research Society, Beta Gamma Sigma, Business Honor Society, American Society of Engineers of Indian Origin, Industrial Engineering and Operations Management Forum, and most recently, a honorary Doctor of Science from Hindustan Institute of Technology Science, Chennai, India. He is an Associate Fellow of AIAA, honorary member of SAE India. He is also invited member of the Research Council of National Aerospace Laboratories. Dr. Bala is an active writer and speaker at various industry, academic, government forums and shares his knowledge and experiences with a wide audience. It's an honor to have you, Dr. Balak Bharadwaj. Over to you, sir.
Sir, you are on
Thank you,
mute.
Venki. Thank you for that great introduction. When one retires from actively working for a company, one actually looks forward to somebody talking to you about things like this.
Thank you, sir.
Good introduction. Thank you. And hey, on a serious note, I'm delighted to be here. Like Venki mentioned, I have spent a large number of years in my career involving with and working with SAE, both internationally and in India. And along the way, you learn many things. And one of the things that I have learned is about the relevance and importance of the standards that we now refer to as SAE Aerospace Standards. Now, they didn't always come, created by SAE. In fact, when I joined the industry many years ago, we used to be very much dependent on what was then called MIL standards, basically developed by the US military organizations because they recognized the need for that. But at some point, they realized that instead of the military personnel hanging on to those and trying to maintain those, it made a lot more sense to hand it over to professional engineers and scientists who are, constantly applying them, thinking about them. So that's kind of how a large collection of MIL standards became part of SAE India, SAE International Aerospace Standards. And like I think our earlier speakers have mentioned, both Ravi and Venki, this is an ongoing activity. Standards are not something you make once and forget about. You have to constantly revisit them, maintain them, upgrade them because technologies are changing, applications of existing technologies are changing, the business requirements, customer requirements, all kinds of things are dynamic. So the standards should really keep up with them. In order for the standards to be relevant, one needs to keep up with them, and which means the standards have to be maintained. And I think so far, to a large extent, I won't say 100%, we do have some people who have been contributing to standards from India, but to a large extent, we have been simply benefiting from the work that's been done by various other people across the world. I definitely think it is time for the Indian contingent to start contributing more. And I'll refer to you in a few minutes areas where we could do that and the benefit of actually being actively involved with that. I don't have too many charts. I wanted to have more of a conversation. Again, I thank SAE India for giving me this opportunity. And I'm also going to be listening in on some of the talks that are following this and tomorrow as well. So we kind of keep up to speed on what's going on. So here are the broad questions that I wanted to spend some time to chat with you about. What are these standards? I think you've heard Ravi's comments. I have my own perspective, not that much different really, but let's make sure we all are on the same page. What are these? And then of course, yeah, it's nice they exist. Are they important for us? And one of the questions that comes up is, are they going to become some kind of a constraint that actually prevents me from being creative? Nowadays, this word innovation is used very, very frequently. People do things that were done 20 years ago. They just didn't know that it happened 20 years ago. And then they say, I have an innovative solution. And now people are worried about, these standards. Are they going to come and prevent me from doing something different? And especially this is a problem in India because in India, we all somehow want to be different. If the rule says, drive on the left side of the road, you'll always find, a few brave souls who want to try the other side. So is my creativity going to be impacted? And then, of course, the other question is, okay, you're spending 2 days talking about all these things. Is it going to help? Is it going to help me in particular? Maybe it helps someone else, but does it help me? So those are the kind of questions that I thought we will spend a few minutes to talk about. If we have some time left over, I'll be happy to take any questions, but not sure how much time we will have. I went to the SAE website just to pick up on exactly how the website describes standards. And there are some very, very key phrases here. SAE, like I said, they are recognized as the keepers of some most trusted collection of scientific data. So when we say standards, we are not talking about Bala's view, Boeing's view, Airbus likes to do it this way. We are not talking about a particular individual or particular organization's perspective. We are talking about, doing due diligence, collecting data, discussing it with various, experts and saying that, look, this is the basis. These are the correct way of doing it, or these are the data that help us to come to a conclusion that this is how things should be done. They are global and they are globally optimized. Many of us use the word optimization somewhat loosely, I would say. But if those of us who have spent time on optimization, you talk about local optimization and global optimization. Here we are talking about these standards as ways to optimize, but optimize globally. That is for the benefit of the larger system. The larger system might be the airplane. It could even be bigger than the airplane. But whatever we are doing is to look at the big picture, and then what it yields us, what these standards contain are processes, practices. How do I apply those processes? And then what products are they applicable to? They do have to do with technology, but most importantly, they are vital to ensure safety, quality, and reliability. All these three were mentioned by Ravi just a few minutes ago, and I'm going to spend a few more minutes talking about those. Website tells you there are a huge number of documents available, and this number is a dynamic number. It keeps changing. So if you start digging into them, you will find more and more. And they have been growing over the years. So I don't see that trend slowing down any time in the near future. Now, if we think about the elements that were mentioned, there were a few things related to starting with letter P. There was quality, of course, reliability was mentioned, and then safety and standards kind of going together. Those of you who have worked with me in the past, they know a different meaning for PQ, R, and S. But in this context, I think they take on a very relevant meaning as well. The SAE definition talked about processes, practices, and the product. That is from the engineer's point of view. Now, but if you think of yourself, I'm no longer working in a particular company. I may just be a customer for a product. I may be somebody who uses the product and wants to have the best experience. So I would be looking for performance of the product as well as the price point. We live in a very competitive world, and if you simply say, I have the greatest thing for you, but you have to pay 50% more, chances are that's not going to be a successful product. People want the best performance, but then they don't want to pay any more. In fact, preferably they would like to find a solution that is actually lower price than what they paid 5 years or 10 years ago. So performance of the product as well as the price are important. And the interesting thing is these are enabled by having the right kind of standards as well. Quality is at multiple levels. There is quality of the design. What is quality of the design? When we do, we talked about how every large aerospace company has a center in India. Now the center in India is going to do work and hand it over to somebody in Europe or US or somewhere else. And we are not going to have each other check, the other person's work constantly. We are going to expect the other person is going to give us the right kind of work. And whatever data, whatever information you design that you provide me, I can plug into the next step and of the process and move on. So there is a quality element when it comes to the design process. There is obviously there is a connection with manufacturing. For example, when you're talking about design, there are connectors that we use. Let's say I'm doing design of an electrical system. If I arbitrarily picked up whatever was locally available, maybe I have experience working at HAL. I say, well, in HAL, we use a certain kind of connectors. I will set it up the same way, in Boeing. And then this is what I send over to the people in the US. They'll say, what kind of a connector is this? We never heard about this one. So even such a simple thing as what is a fastener to use, what is a connector to use in an electrical or electronic context become very, very important. And these are part of what we include in the standards. Material selection is the same way. When you talk about manufacturing, what is the manufacturing process standard? If it is manufactured in Hyderabad, for example, will it be doing the same thing? Will it have the same longevity as what I made in some other location, maybe in Europe or the US? These are questions that as a manufacturer, one would have. And again, this is another place where the standards come in and say, when you do the manufacture, this is how you do it. These are the steps that you follow. And if you follow these steps, you will get the right kind of quality. And then that quality I can not only accept, but I can safely integrate into the rest of my process as I continue to build the product. The collateral here, what I mean is the collateral influence of my process, especially in manufacturing. There is a lot of, depending on what kind of work you're doing, there are wastes being created. It could be impacting the environment, you know, the air quality or the water or the amount of, you know, residue that we create when we do the work. The world is getting more and more sensitive to these things. I cannot simply say that, well, you know, there are strict standards in Europe for, you know, for environmental control, so let's do it in Gujarat where, you know, we can do whatever we want. No, Gujarat has its own standards. Bangalore has its own standards. And in fact, we are all getting to the point where what we do should not only, you know, have lesser amount of emissions when the product is working, but we should also be thinking about what am I doing to the environment as I'm manufacturing the product. So the collateral impact is related to the quality of the air and water and the atmosphere at the beginning and at the end of the process. And there are standards connected with those. User experience doesn't sound like quality related thing, but very much is. You know, when we are buying these aerospace products, these are not cheap, they are very expensive. And when I eventually get my hands on them, what is the experience that I'm expecting? I'll just give you a small example. You know, Boeing and Airbus actually have been selling large number of commercial aircraft to the Chinese, because the China, you know, the aviation market has been booming for almost, you know, 15, 20 years now. And they are the largest market in the world. And what we found, both the companies, what they found early on is that whatever cabin design that they made was all based on the requirements of European and American travelers, who are generally much taller. Of course, the Chinese are getting taller also right now, but if you imagine the older generation of Chinese, and I would say somewhat similar in India as well. So the Chinese traveler was not able to reach up to the cabin. And then there have been studies done to look at what do I have to do? How should we make the cabin, you know, content? How do I enable, make it easier for a Chinese user to load their luggage, you know, handbag up in the cabin, so that, you know, they don't get frustrated. They can say that, look, this is a great airplane. I had a great experience traveling in this airplane. So one has to think well beyond what the engineer is sitting and doing at their desk or, you know, in the shop. Now, reliability is another thing. You know, we all think of reliability a certain way. Again, my input is that we need to think about it from the point of the user. How repeatable are things? They work well the first 10 days. Will they work in the 20th day, 200th day, 2000th day? That is what is the expectation of the aerospace product. And it doesn't matter which part of the world these are made, we would expect them to operate, because eventually when an Airbus or a Boeing, you know, sells an airplane, nobody comes to come and inquire which country or which company made this switch that is malfunctioning. People will turn around and say, hey, this is not working. You guys gave me a bad product. So the reliability of every little piece that goes in the airplane is important, and the repeatability of the operation, whatever the function is. It could be as simple as a switch in an entertainment system. It could be something as complex as a cockpit display, or you know, the switches and the avionic systems that are, you know, not even visible to most of us. So reliability basically boils down to trust. You know, do I want to go back and buy more of these airplanes? Do I want to buy more airplanes from this particular company? And in order to do that, people are going to go back and look at the reliability. And any one of us, all of us, who are contributing to the design, the manufacturing, and various other aspects of building these airplanes. Again, remember, these are all global airplanes. Any one of us who's contributing to that needs to keep in mind that we are also contributing to that element of trust, which is being created And if we create trust with our partners, then we can expect to get more work. If our company creates trust, then our company has a reputation, and that reputation helps you to generate more business. So these are all very intricately connected. Safety, of course, I don't have to tell you too much about that. In aerospace, safety is supreme. Now there is an element of supply chain that I wanted to bring up, which is connected back to the performance and price. Yes, I like to make things low cost, and the way the aerospace industry has evolved over the last 2 or 3 decades is by taking small pieces of the total work and saying, look, this small company is better suited to doing that. They can do it more efficiently. They can do it at a much more affordable price than the big company can do. And that is how Boeing and Airbus, all used to be companies where everything was made in-house. Today, of course, they dole out 65, 70, sometimes even 75% of the actual work to be done by suppliers somewhere else. And the suppliers have their, sub-tiers, sometimes going down to, third tier or fourth tier even. So that whole supply chain, the dependence of the company, the bigger company, OEM, on supply chain is very, very strong. And the supply chain will work efficiently, will work with reliability, with quality, only if everybody in the supply chain is actually following standards. So again, the standards become critical when you are operating in the context of a supply chain. And any one of us, and I would say every one of us, is part of the supply chain, including the OEM in some way, because OEM is part of the supply chain, for the end customer. So it is extremely important for us to understand that relationship. That yes, there are standards. Standards have to be applied, and adherence to standards is what keeps that trust going between the whole ecosystem. All right. Now what happens if we don't have standards? You can probably relate to some of these pictures. Certainly the right side ones you can, I'm sure. How many times I was just reading, looking through some of my collection of pens from the years, and it's just amazing how many different varieties of refills there are. And there are pens that I have. The pen itself looks wonderful. It doesn't work anymore because it hasn't.
Are you sharing a screen?
But then if I want to find a refill for it, I have no idea where I would go. We all have, at home, at the office, collection of cables, because there are so many different connectors today. In fact, this is not even a complete list. What I'm showing you is just an example of USB cables. And then there are the video cables and the power supply cables.
Hello, are you sharing anything?
I am. Okay, so looks like
we're not able to see anything.
Okay, hold on. Previous chart didn't have too much, but this chart. Okay, there we go. I think I'm losing my.
We are not able to see the screen, sir.
Okay.
Your
presentation. You had spoken up earlier. Okay. How is this now? Better?
Yeah, it is coming up. If you could put it on slideshow.
Yeah. Now I'll go there.
Sir, I have a request. We are running little tight on the time, so.
Yeah. I don't have too many charts here, so.
Okay. Sir, sorry about that. So.
Well, this is. Am I surprised, Venki? I'm not at all surprised.
Over to you, sir.
Okay.
Thank you.
Okay, so the what you missed was this chart, which is not a whole lot, and you missed this chart again, not a whole lot that you missed. But this one, I think, is worth looking at, right? I was talking to you about the variety of refills that are available in the market, variety of connectors, USB connectors, the number of batteries. I still have old watches which have batteries where I don't know where to find a refill. So when you don't have standards, people will create their own. And so now you might say, no, okay, that was olden days. Now we are all much smarter. Are we really smarter? Just take a look at the EVs. How many EVs are there in the market, and do they all have the same kind of charging system? Tesla has made their own. Tata has their own system for theirs. Now there are other companies who are entering the market. They will probably say, "Look, I'm not going to follow someone else. I'm going to use, what I want to create because it's easier for me." So in the early stages, when any kind of a new product or a technology is being brought in, uh, there is a tendency for each one to do their own thing. And there are plenty of examples. There used to be something called Sony Betacam, and then there was UHS. In the computer world, you have the Apple system and the Microsoft operating system. Two dominant systems that have survived. And but if you want to think about mass usage, I mentioned price earlier. When you standardize, then the price of the product goes down. Now, no one company will have monopoly. There will be other companies who can step in. They can create, that same product. But of course, if you want to ensure quality, that is where standards come in. So if you choose not to use standards, you can do that, but then you run the risk that other people may not accept your design. They may say, look, I don't want to be stuck with you and your particular way of thinking, because who knows what you will be doing. Even if you're a successful startup companies, what do successful startup companies do? They basically sell it to somebody else and move on and say, okay, now I'm going to start a whole new business. And the acquirer of your business, they may have their own ideas. So in the interest of longevity of your product, in the interest of the customer getting continued support, it is very important that we think about standards. So when we are talking about electric vehicles, for example, or the drones, these are new technologies that are evolving, which don't have many standards still defined today. And today, the Indian engineers don't have any disadvantage in these areas compared to, let's say, 10 or 15 years earlier in existing areas, because the EVs, whether it's EVs or the drones, these are equally new to India as they are to Australia or US or UK and so forth. So these are all areas where I think we can contribute. Now, here's an example. This is pretty much my last chart. Here's an example. If you don't recognize this, this is on Mars. This was a vehicle that was sent over to Mars. There was no particular need to worry about standards for building a vehicle like this, because this is a unique vehicle, one of a kind. Sometimes standards will come and impose extra restrictions for you, and you may say, look, I'm setting this, it's a one-time usage. I don't want to burden this particular design with extra complication of standards. But examples like this are extremely rare. For the normal engineer, normal product, I think adhering to the standard makes a lot more sense, because that is what helps us, both the designer, manufacturer, as well as the customer in the long run. So aerospace is a complex and globalized industry. I think you all know that. If you want to be part of this ecosystem, you must be able to work seamlessly with others. And the aerospace standards become a very, very important part of that seamless working together. So these are the messages I just wanted to leave you with. And congratulations again to the Aerospace Board and SAE India for organizing this event, and best wishes for the rest of the conference.
Thank you, Dr. Bala. Impressive and informative like it has always been. Having listened to Dr. Bala on the importance of standards, ladies and gentlemen and members, we are now going to get a cockpit view of the Aero Standards program of SAE International. Fasten your seatbelt and relax. Here comes the Director, Aero Standards Program from SAE International, David Alexander. David has been with SAE International and its affiliates for 17 years and is based out of London, UK. In May 2016, he assumed the role of Director Aerospace Standards. In this role, Alexander is responsible globally for the strategy and operations of the SAE Aerospace and System Management Standards, comprising of over 7,600 consensus standards maintained by more than 180 technical committees. This includes the management support for the SAE Aerospace Council and SAE Executive Standards Committee and involves leveraging standards to work across SAE International portfolio. Supported by SAE staff in London, Paris, Shanghai, and across the US, program activities include relationship with industry, associations, aviation authorities, government stakeholders around the world, and strategy for standardization in areas as diverse as AI, electric aircraft, additive manufacturing, human factors, and quality. Prior to joining SAE Aerospace Standards Operation, David worked on the NADCAP accreditation program through SAE's affiliate organizations PRI, Performance Research Institute, and he holds a BA Hons degree from the University of Manchester. In this engaging, accessible, intimate history of the standards, we hope David will pour through the genesis, names, stories, and achievements of SAE Standards. I have a request to you, David, because Madam Ronda has to catch a flight. So whatever you could do on the timeline, that will help. Over to you, David.
Okay, thank you very much. Thank you. Okay, right. So
Over to you.
let me share my screen there.
It's coming up.
It's coming through.
It's still coming up.
There we go.
I see a lot of clouds. Oh, it has come up. Please put it on slide view. Thank you. Over to you.
We're seeing 2 slides, so you may have to set that.
Yeah.
Okay. Are you seeing the full screen view or the presenter view?
We are seeing the working view, not the full screen.
Okay.
You can press F5, that should help. Or if it is easy, SAE India office can share, because we have the presentation. If that is okay with you, David. David, you are on mute.
Oh, right, there we go.
Can we share the presentation deck? SAE India can share.
Right, let me have one more go.
We are sharing.
Okay. Sure.
Vijay? Okay, we are on full view. Good to go. Over to you, David.
Okay, great. Thank you very much. So, thank you. So it's an absolute pleasure and honour to have the opportunity to partner with our friends and colleagues at SAE India and the Aerospace Forum. And you know, Venki and Ravi Kumar and Dr. Balak Bharadwaj have already, I think, set the scene magnificently for the aerospace standards. We really appreciate the partnership, the organisation of the event to speak with the aerospace community in India. I know a lot of work has gone in, and it's going to be a tremendous couple of days. I'm very excited to be followed by some of the world's preeminent leaders and experts around the world who are actually defining the realization of innovation, ensuring safety, and advancing the industry. And I give thanks to them for everything that they do. For now, I'm going to set the context by giving a quick overview of the SAE Aerospace Standards program, as well as a short overview of the NADCAP program, which is gaining traction in India as well. And the main message, I think, is that we value your engagement, your participation. We welcome it. So please consider engaging with SAE Standards and our committees to contribute to the industry, but also, as was mentioned before, to develop yourselves and also your networks. So if you go to the next slide. Thank you. So, SAE International is, has been stated, a global organization. Our mission is to advance mobility, knowledge, and solutions for the benefit of humanity. And we do this in many ways, as well as standards. Now, of interest, some of the key topics, and some of these we'll be hearing about from experts throughout the next couple of days. Some of the key topics that SAE's board of directors has noted will be important in the coming years. Things like advanced manufacturing, advanced materials, advanced propulsion, including electrification, everything automated and unmanned, the connectivity, and of course then the cybersecurity that we need to mitigate threats. Then looking at blockchain, quantum computing, and then underlining all of this again is that development of the workforce, whether it's through professional development and training, through the consumption of content, or through the participation on standards committees. Okay, so next slide, please. So SAE is a historic organisation. It was established first in 1905 by Henry Ford and other automobile pioneers. But then in around 1915, the burgeoning aviation community joined, led in a large part by Orville Wright and his brother, and from then many of the aviation pioneers were actually early members of SAE, shaping the consensus building around the aviation industry. You go to the next slide. And so rather quickly, they came together to develop the very first aerospace standard. And this was published in an SAE journal in January 1917. It was for an aeronautical spark plug that was formulated through cooperation between the aviation industry in the USA, Great Britain, and France. So that was the first example. I think it fits very well with what Dr. Bala had to say about the value of standardization, and it continues to be our DNA. So next slide, please. So since 1917, the very first one, the program has grown enormously to really cover all aspects of the aerospace environment, as well as looking more specifically at some systems management aspects as well. So if you go to the next chart, I'll show you some numbers. So it's a very big program. As you saw from those organizational charts listing all of the different SAE technical committees. So there are around 180, more than 180 technical committees, comprised of over 8,300 experts from around the world who are maintaining over 7,600 SAE standards. They do this by convening. In normal times, we will manage over 125 meetings around the world. Last year, of course, we had to do a digital pivot and connect everybody virtually, but that was very successful. We had great leadership from the industry, and we held 2,620 virtual meetings in 2020 and very similar for 2021 as well. But of course, looking forward to getting back together very soon. Last year we published 657 aerospace and systems management documents, new and revised, and there are around 1,300 current works in progress. So, so it's a very, very big operation, very, very important standards. Okay, next slide, please. So the standard development process is, in essence, very simple. There's a need that comes from industry or from the government regulators or procurement agencies. The committee, comprised of the experts, then works on the technical development of the document. Once the committee's agreed from a technical perspective, it then goes to our Aerospace Council or Systems Management Council from a governance perspective to look at the due process. And once that's been satisfied, it then goes for publication, is available for the global industry to use. Now, of course, in reality, there's a lot of consensus building, comments and resolutions to improve the document, to make sure that it meets the needs of all the different stakeholders. But it's a very open and transparent process. Next slide, please. And talking of the governance, so for example, the SAE Aerospace Council, which sets the vision and the strategy for how the program and the committees run, is comprised of leaders not just from around the global industry, but also from the research community and from government and regulatory agencies. So have a very, very big role in shaping and indeed using the standards. So this is a good microcosm of the kind of organizations that are involved in shaping the standards. Next slide, please. And one very important aspect of this is in the public-private partnership, and particularly in the civil or commercial world, standards are increasingly important in being used by the regulatory authorities. So right down from ICAO defining SARPs and manuals to the national and supranational authorities like EASA and FAA, Transport Canada, CAA, JCAB, and so on. They are all using a large number of SAE standards to define the certification requirements, the advisory circulars, the acceptable means of compliance, and the policies. So by working on the standards and shaping the standards, you're also shaping the certification process in partnership with the government. Next slide, please. And as you know, the aerospace industry is extremely vibrant at the moment, with many different facets and segments and vehicle types, and that's reflected in standardization environments. So over the last few years, there have been a very large number of new committees that have been formed to manage some of these new concepts, new processes, new products, and new technologies, many of which you'll be hearing about in the course of these 2 days. But this is an example that when industry is looking at turning innovation into reality, they go through standards. Next slide. So as Dr. Balak Bharadwaj had mentioned, there is some engagement from the Indian aerospace community on SAE standards, and we very much value and welcome that. So there are 45 individuals who are on the SAE committees as liaison or voting members. This is a total participation of almost 80, because there are several contributing to multiple committees. There are 6 who are voting members who are listed below, and again that shows a very high degree of engagement in the standards process, actually influencing the standards, and that's very much appreciated. I call out our friend Dr. Ravi Kumar, who's actually at the leadership level, so actually providing such a high degree of leadership in chairing the G31 Committee on Electronic Transactions for Aerospace. In addition to that, we have 72 liaison members and 54 who are keeping track of SAE standards through the mailing list. We would like to really put this out as a welcome and an encouragement to join to join your colleagues and compatriots in joining the SAE committees. Kerry Rohall tomorrow will go through a presentation on how you can do that, but it's a very open process. Everybody's welcome. So have a look at the areas, the committees that define your interests and your expertise, and then work with my team to join these committees and start to engage in these wonderful committees and networks to shape the standards. Next slide, please. And while there's cutting edge technology going on in the committees, we're also looking at where the cutting edge is from a standards development organization, both and through 3 platforms in particular. Standards Works, which is the workspace, the platform on which the SAE standards are written and balloted and ultimately published. That's really important to have a cutting edge platform for the standards to be developed as efficiently as possible. Then they're placed on our Mobilus platform, which is a research platform with all of SAE's content, whether it's standards, technical papers, journal articles, magazines, white papers, and also professional development and training content. So it's a great research platform. Then Oncue is our very newest platform, and if you go to the next slide. Thanks. So the Oncue digital standard system is a new cloud-based platform where we've actually using AI digitized all of the SAE parts and materials standards so that users can go in and actually identify all the different characteristics within a standard and then start to tie those to products. So this is really a real next generation step. And there's a video which would be very good to watch connected to this slide as well, which we'll be giving to you. So then the rest of the aerospace portfolio, not just standards, but we have our Edge reports, our collegiate design systems, our Journal of Aerospace, lots of training and development again on that Mobilus platform. And if you go to the next slide, and then every year we have our Aerotech conference. It's our premier aerospace exhibition and conference. Next year it will be in Pasadena in California in March. The door is still open for abstracts. They're welcome until the 4th of October. You see some of the key focus areas there, very much future orientated. So we really would welcome any more abstracts to go in. It's a very prestigious event, and again we welcome your input into this. Okay, and the next slide. And then, as has been noted, SAE is not just all about aerospace. We also work a lot with passenger cars, commercial vehicles of all kinds, and we're starting to realise, and particularly through standards, these cross-sector synergies and the multimodality. So things like batteries, electrical systems, hybrid electric propulsion, crashworthiness of vehicles, everything automated and autonomous, micromobility, and then the data concerns. Cybersecurity, and then looking at lessons learned for production, manufacturing of materials and parts, and all the quality associated there. So very good crossover, and of course SAE India very well placed to lead here as well. Okay, next slide. So this is the end of the overview, the SAE overview slide. So we encourage you to discover what's relevant, get engaged, and then look for opportunities for participation and leadership. And again, thank you to SAE India and the Aerospace Forum. Now, as noted, we did have the NADCAP update as well, but perhaps we can work to insert this into another part of the program. So I can turn over to Ronda Collins.
Thank you, David Alexander. I think you gave us the clear and a 30,000 feet view. You said it. Standards are integral part of what it meant to be a SAEN or SAE Indian. Thank you, David. So, ladies and gentlemen, there is a slight change in the agenda because Madam Ronda has to catch a flight. So, we will now request Madam Ronda to continue with this. And there is only one logistic announcement. There is going to be 2 sessions. The session which you are in is called Parallel Session 1, and Parallel Session 2 is already on. Where do you get it? You get it in the chat box, you get it in the email. You'll have to click and join if you want to join those sessions. May I now request Satish Tokala, my co-MC, to introduce Ronda quickly. Over to you, Satish.
Thank you. Thank you so much, Venki. Good evening, all. Welcome to this track 1 of Aero Standards Workshop. I'm Satish Tokala, working as Aerospace and Defense Industry Manager at MathWorks and Organizing Committee member of Aero Standards. I'm also joined by Sandeep Duche, who is Specialist Engineer of Aerospace at Eaton and Organizing Committee member of Aero Standards.
Satish, your voice is
Is it better? Sorry?
Yeah, I can speak up a little. Fine.
Okay, yeah. So now, without further delay, let me introduce Ronda Collins, who will be delivering a talk on HM1, Integrated Vehicle Health Management Committee. Ronda Collins is a technical fellow at Collins Aerospace, USA. She is an industry-recognized leader in the development of standards and best practices for PHM solutions. She holds 4 PHM-related patents and 1 invention disclosure. She has authored numerous aerospace technical standards, conference papers, chapters, and SAE Edge research reports. Ronda is a member of SAE International Board of Directors and the Audit and Risk Committee. She has had numerous SAE leadership roles, including chair of the Integrated Vehicle Health Management Steering Group, chair of HM1, G32, G31 Technical Committee. Ronda is the first female fellow of PHM Society. Ronda received several prestigious awards, including Society of Women Engineering Prism Award, Outstanding Aerospace Engineer Award from Purdue University, SAE Rodica Bancu Award for Technical Excellence and Leadership, and SAE James M. Crawford Technical Standards Award for Outstanding Achievement. With that, Ronda, over to you.
Thank you, Satish. Can you hear me okay?
Yes, loud and clear.
Yeah. Thank you. Well, first of all, thank you very much for accommodating my itinerary change today. I really appreciate being able to go ahead and go a little bit earlier than planned. And it is certainly a pleasure for me to be here to speak to you about the IVHM HM1 committee. This is a committee I have been involved in from day one. I'm one of the founding members, and I'm currently the chair of the HM1 committee. So I'm pleased to be able to give you a brief overview of the committee, and hopefully maybe you'll be interested in participating in the committee in the future. Next slide, please. So this committee was formed in 2011, and it was the outgrowth of a steering group that we formed back then to consider what the future looked like for health management. At the time, there was another committee, and still is, the E32 Committee for Propulsion Systems Health Management. And this committee has been around since the late 70s, and they're coming up on their 100th meeting here very shortly. And they have always focused on engine propulsion, APUs, and at the time, powertrain. Well, as aircraft became more capable of producing a lot more data from aircraft systems and components, we realized there was a true need in the industry to be able to do prognostics and health management of other aircraft systems and components. So a group of people, experts from the industry, got together and formed the steering group. And from the steering group, then we formed the HM1 committee to focus on developing those best practices, those standards for aircraft level health management. We held our very first meeting in San Francisco in April 2011. And our 8th meeting was actually held in conjunction with SAE India in Bangalore in October 2014. And several of our committee members, including myself, actually participated in that workshop in a wonderful panel session. Our next meeting is coming up in a couple weeks. We're going to be in Cedar Rapids, Iowa, which is where my company, Collins Aerospace, is based, or my department, I should say, is based in Cedar Rapids, Iowa, the former Rockwell Collins. And our 25th meeting coming up next year is going to be international, and Bangalore is on our short list. The committee will soon vote whether or not we're going to go to Bangalore, Lisbon, or Cranfield University in the UK. Next slide, please. This committee was formed to really focus on gathering all the expert information and develop the information reports, the recommended best practices and standards around the area of aircraft level vehicle health management. And we didn't want it to just be focused on aerospace. We did start out focusing initially on aerospace, but we quickly realized and knew that we wanted to expand that to include ground vehicles. So we wanted to address all the integration issues for health management systems, not only on the platform itself, but at the fleet level. And we wanted to provide the standardization that was missing out there for aircraft level health management. Again, we had propulsion standards, but we didn't have anything that applied to any of the other aircraft systems. We didn't even have common terms that we used to describe things. We didn't even use parameters the same way. So we really needed this committee to put that together and then to provide the technical guidance on how we're going to work together. And I'm actually very pleased to say we've been very successful in working with the regulatory bodies, and we have some exciting regulatory changes that are coming out next year in 2022 that are a direct result of the hard work done by the HM1 committee and the E32 committee and the Structural Health Management Committee out at SAE. So very excited about that. More to come in 2022 on that. Next slide, please. So the scope of this committee is we have a really big scope. We're actually focusing on civil aircraft, both the fixed wing and rotary wing helicopters, as well as military. We also are focusing on unmanned aircraft. We don't have a lot on that platform at the moment, but that is still within our scope. But we also focus on the equipment, the systems, and the software it takes to do IBHM level. And also a very important part is the maintenance part. So it's one thing to be able to collect the data and analyze the data, but you really need to be able to apply that to maintenance to take the action. And so that's the scope of our committee, to focus on all those areas. Next slide, please. I am the current chair of the HM1 committee. The vice chair is Brian Tucker. He works for Bell Helicopter out of Texas. Kevin Byers is our SAE staff support, and he's absolutely fabulous. Currently, our committee has 43 voting members. We have 228 liaisons, 30 mailing list recipients, and we have 13 staff engineers from SAE that support us on a regular basis. Now, to become a voting member, you need to attend 3 consecutive meetings and be interested in participating in working on documents and voting on documents. And then the committee will take a vote and hopefully vote you on to be a voting member of the committee. It's very important to really watch the number of members that we have, our voting members, because we have to be able to achieve a quorum. We have to be able to achieve that a quorum to conduct meeting business, as well as to successfully ballot our documents. So that's another reason why we have a large number of liaisons and a smaller number of voting members, is because we need to make sure that persons that become voting members are committed to the committee and are committed to participate and help us achieve that quorum. Next slide, please. Our cadence is we meet twice a year, in the spring and the fall, and that's very typical of a lot of SAE committees. We plan our meetings 18 months in advance. Now, COVID has really been a challenging impact to all the committees, because we had our locations, venues, and hosts all selected, and that all had to change and go virtual. And our meeting in October will be our first face-to-face meeting in 2 years. So pretty excited about that. Again, as I mentioned, it's going to be in Cedar Rapids, Iowa. We're going to be going to West Palm Beach, Florida in the spring. And then in the fall of 2022, international, and perhaps we'll be there in Bangalore at that point. Next slide, please. So what does the committee do? Well, one of the things we started out is trying to think about all the areas we wanted the committee to really touch. What documents did we want to produce on what topics? And we broke it down. We created this document tree, and this is a living tree. We update it regularly as we decide on which documents we're going to add. So what's shown here are the documents that we are already published or are in work. So we are going to focus on organizational goals for businesses and whether or not they're going to make a decision to do vehicle health management. So like the cost benefit analysis falls in there, and human factors and some guideline overviews. Then we're focusing on what the system requirements are to have vehicle health management. We're focusing on the requirements for the system architecture, and then also for the detailed design phase. So for those of you that are engineers, I'm sure you're very familiar with a lot of these phases. And then the verification and validation process. Where we still do not have any documents for future work is in the system implementation. So we'll be focusing on that here shortly. And then for sustainment, maintaining the system once it's in the field. So again, we use this document tree as our roadmap to where we're going in the future, to make sure we know where we're at now, and to also help people who want to read or purchase some of our standards, our documents. This is how they can decide which one might be best for them to meet the needs and to fulfill the information they're looking for. Next slide, please. So just briefly, I've got the documents that we have published listed here. This first set of documents here are information reports. So these are documents that are what our committee members or industry experts believe is important information to get out there for the industry to consider. So they're not standards, they're not necessarily recommended practices, but they're really useful information that we have pulled together based on our consensus of what's important in the industry and what information needs to be out there. Next slide, please. This next set of documents are recommended practices. So these are documented practices of what is happening in the industry today that our community members have come together and said, this is what we agree to be the best way forward. And again, all these documents are updated every 5 years. And you can see we already have a Rev A on the cost benefit analysis because we found there might be a better way to do something else, how to do the CBA. So we maintain these documents every 5 years. We update them or sooner if we need to. And these are really the core of what we do. This is what we're saying is the best way to go forward with vehicle health management in the industry. Next slide, please. And then we do have a number of aerospace standards. Now, I do want to point out that we inherited some of these standards. There was another organization years ago called RITA that focused on helicopter usage and health monitoring. And we have inherited those documents now. They were in the E32 committee for a while, but when powertrain moved over under the aircraft vehicle level, IBHM, we received those documents. So we maintain these documents, and they are out there as aerospace standards, have been around for many years, but they are very accurate. And again, we are at the point where we're going to be revising some of these Rev A's to Rev B's here shortly. Next slide, please. We do have 2 documents that are currently published that are joint aerospace and automotive documents. The first one is using a reliability model to optimize maintenance costs. And then the second one is design and runtime information for health-ready components. So these documents, again, are applicable to both automotive or ground vehicles and aerospace. So we publish them out of our committee, but they are, again, applicable to ground vehicles as well. Next slide, please. We have a number of documents that are in progress, including one on atmospheric corrosion monitoring. The next one, 6290, Guidelines for Development of Architectures for IBHM Systems. I'm pleased to say that that ballot's going to open today. So we hope to have this document published, if not by the end of 2021, maybe early 2022. So it's just a matter of going through the ballot process and then getting it approved by the Aerospace Council, and then it's out for publication. We also have the verification and validation of IBHM systems document that's well in progress and should be coming up for ballot in the next 6 months as well. Another document that's very, very important is the 7122 document. And this is using integrated vehicle health management for maintenance credits. And this document is going to align with the regulatory changes that I mentioned that were coming in 2022 that will allow airlines to use health management data to alter their scheduled maintenance programs. We were asked to write this document by the FAA. So we are working on this document and hope to have it published in 2022 to coincide with the regulatory changes that are coming out at the same time. And then the last document we're working on is a document that we've been working on for many, many years. It's the condition-based maintenance. So this is really coming from the military side of the industry. And it's been going on for a long time, mostly because the military has had back and forth on condition-based maintenance versus condition-based maintenance plus. So really been trying to work that, and hopefully we can finally get that document published in 2022 as well. Next slide, please. Next, okay, that's my last slide. So I do apologize. I know I went a little fast. Again, I got to catch a flight in less than an hour now. And I would be happy to answer any questions you have. There's my email address. You can also reach out to Satish or Ravi, and they can provide you the information to contact me. Again, as the chair of the HM, well, none of our meeting coming up in Cedar Rapids, so we'll have people on site in Cedar, but we will also have the virtual representation. I realize the time change might be a little difficult for you, but we try our best to try and accommodate members because they do come from all around the world, and we would really welcome your participation. Back to you, Satish.
Sure. Thank you so much, Ronda. It's an informative talk providing insights of HM1 and the various activities and initiatives the committee is driving. So thank you so much. So we will close this first talk here. And now let's take a break, quick break. So it's a 10-minute break at 6:30 right now on my clock. So let's get back together at 6:40, 10 minutes from now. And the same link will continue. The same WebEx link will continue for this track.
Thank you.
Thanks, Ronda.
Yeah.
Hope everybody is getting refueled and be ready for the next phase of the flight in 2 minutes. We will start on that. Okay. Welcome back, everyone from the break. So hope you're re-energized again to continue with the workshop. After
Please, you are muted.
Oh, sorry. Okay. So after hearing a wonderful talk from Ronda, Sandeep, I was just thinking, about, because, we got good insights from David Alexander providing the overview of, various activities or initiatives by SAE, right? I was just wondering, there is so much that's happening, right, by SAE. So how many technical committees, would be maintaining this SAE Aerospace Systems Management Standards program?
Yeah, yes, Satish, that's a very interesting question. I think David Alexander also helped us out to get that information in earlier slides. So around 180 committees are there and around 7,600 consensus standards are being worked on. That's a big number. I think we'll learn some more about these committees as you take ahead us.
Yeah, 180, right? 180 technical committees, right? So it's a big number, right? So in this track, the way this track is framed, to hear from 4 of such committees. We just heard from Ronda about HM1. And now in the next 1.5 hours, we will learn about initiatives and activities from other 3 committees, that is G31, G32, and G34 in this track. So now let's move on to the next talk by Dr. Ravi Kumar, providing insights of G31, Electronic Transactions for Aerospace Committee. It's my pleasure to introduce Dr. Ravi Kumar, who is Associate Vice President and Head of Advanced Engineering at Infosys. He is the chair of G31 and member of HM1 technical committees of SAE International, contributing to various aerospace standards development. He has led many innovation and applied research projects over the past 25 years. His areas of expertise include mechanical structures and systems, knowledge-based engineering, composites, artificial intelligence, robotics, autonomous systems, AR, VR, Industry 4.0, and so many to continue. He is involved in the development of commercial products like Autolay, Nia Knowledge, and KRTI 4.0. He played key role in the development of Industry 4.0 Maturity Index under the umbrella of Akatech, Germany. Dr. Ravi Kumar has published over 50 technical papers and 5 patents. He won many awards, including James M. Crawford Executive Standards Committee Outstanding Achievement Award from SAE International and Corporate Excellence Award from American Society of Engineers of Indian origin. With that, Dr. Ravi, over to you to walk us through G31 activities.
Thank you, Satish, for that wonderful introduction. Are you able to hear me clearly?
Yes, Dr. Ravi.
Okay. First of all, thanks SAE India, SAE International for giving me this wonderful opportunity to interact with you. Good morning and good afternoon, good evening to all of you who are joining this particular meeting across the globe. What I'm going to walk you through is one of the important technical committee, that is G31 Electronic Transactions for Aerospace Committee. Alternatively, this is called as Blockchain Committee as well. Of course, this all talks about the digital data transactions. That is what this committee is looking after. Okay. I'll just give a kind of quick summary in this particular broad sections. I'll just give you a quick summary where this G31 committee falls in the overall Aerospace Council, and what is the need for this G31 committee, and we'll give you a kind of quick overview about this particular committee and who are the contributing organizations of this committee, and also what are the standards that we have published so far and what are the standards that are currently in progress. Okay, so that's what I'm going to present today. So if you look at the overall technical committees, right, David has showed the wonderful chart that is basically SAE Aerospace Council organization chart. And if you look at this particular Aerospace Council charts, there are various groups who are representing these standards. And one of the important group is Aerospace General Projects Systems Group Committees. Okay, so that's where this particular committee, G31, Electronic Transactions for Aerospace, lies. Apart from this particular committee, we also have G32, Cyber Physical System Security, G34, Artificial Intelligence in Aviation. In fact, we are going to have a presentation from both of them subsequently. So that's where this committee resides, and this is one of the youngest technical committees. Okay. So what I'll do is I'll quickly walk you through what is the need for G31 committee. In fact, Ravi and Dr. Bala has given a kind of wonderful insight about how complex is the aerospace ecosystem is. So if you look at aerospace industry, it is pretty complex. A typical commercial aircraft will have a life of 30 to 40 years. Okay, so that means an aircraft is designed and manufactured, and it is being operated by two generations together. Okay, each generation you take it as 20 years, but 2 to 3 generations are going to maintain that particular aircraft. And it has a huge number of stakeholders across the board, whether it is the OEM, subsystem supplier, or the component supplier, or the regulator, or the operator, okay, or the maintenance service provider, that is basically the MRO, or disposal service providers. Okay. It has a huge life cycle, whether it is starting from the product definition and engineering side of it, or the manufacturing and integration part of it, or testing, certification, delivery part of it, and operations and maintenance, which is a very long cycle, and the disposal part of it. During this entire life cycle, huge amount of data that gets exchanged, both the physical parts, basically the aircraft parts and aircraft systems, subsystems, and things like that, and also data associated with it. Okay, and this data need to be maintained and managed very well, because regulatory compliance, all the things are there. And if we are in a particular world, every 2 to 3 years you have technology cycle that is out there, and almost within a span of 5 years technology is getting obsolete. Okay, so that's a kind of challenge that we have. How do we collaborate in this complex ecosystem? How do we manage this data that transferred across this ecosystem smoothly? Within an enterprise, it isn't easy to maintain because it comes under one single umbrella. But when it goes from multiple organizations, it is very tough. Okay. In fact, if you just look at it, the complexity next level, these are some of the data sets that gets exchanged. Okay, these are sample data sets. I just taken a small snippet out of it. Okay, what is the data that gets transferred between manufacturer and operator? What is the data that goes from manufacturer to the regulator? What is the data that goes from operator to MRO? It's a huge amount of data. And how this transaction happens? What is the traceability of this particular transaction? How do you maintain the security? It's a huge problem that industry is facing today. Of course, even though earlier it is all paper-based, post the paper-based, all the digital technology that came in, even the digital technology, keeping track of the documents, which document has been released when, and how the entire aircraft is serviced, against whose documents, how the approval process has been done. So it's a pretty complex altogether. Okay. So that is the reason what we felt was it is very essential to have a system in place such that it will help the interaction or the collaboration across the board, whether it is in a business function level in an enterprise, or at an enterprise level, or at an extended enterprise level, or the ecosystem level. And essentially, we need to have this kind of transaction smooth, efficient across the value chain. And also, we need to maintain the cost of operations, especially the post-pandemic era. It is very difficult to manage the costs. Okay? You need to make sure that it is efficient, it is cost effective, and also it should help in improve the overall safety of operations, health of employees, health of the ecosystem, okay, and also keep the entire environment sustainable. Okay, so those are the broad things that one need to look at it. That is the motive behind this particular G31 technical committee, looking at some of these data standards and see how do we manage the complexity in these data standards, digital data, and essentially to address all the aspect of digital data and transactions from concept to disposal, covering the accuracy part of it, interoperability part of it, traceability, security, integrity, privacy, intellectual property, regulations, and policies. So that's the overall context. And with that particular need, we formed the G31 Technical Committee. Okay. And one of the important technology lever that will help in this entire ecosystem is the blockchain. Blockchain is one of the beautiful technology that is out there that can help in building the trust and collaboration across the aerospace ecosystem. Okay. So you just look at it, a typical blockchain network like this, okay, where everybody interacts with this particular network, whether it is a manufacturer or supplier or the owner or the lessor or the airliner, insurance provider, they all can come onto this particular network and can interact, transact. Okay. So whatever data that goes across, all the records of the asset transfer can be put in a shared ledger. And also we can use some of these important concepts like smart contract to automate the process. This particular technology helps in eliminating the middleman, reduce the transactional friction, time and cost savings, and also it helps in role-based access, data privacy, and authenticity part of it. So that's the overall technology landscape that we have looked at it, and that is the need that was there to create this particular technical committee. So what I'm going to do is I'll just give you a kind of quick snippet about the aerospace G31 electronic transaction for aerospace committee overview. This is a mission of this particular technical committee, essentially to develop standards for sharing electronic data and transactions within the aerospace and space transportation ecosystems, okay, both airborne as well as ground, addressing both manned and unmanned from concept to disposal. So it's a broad mission that we have. The area itself is broad, and essentially we are looking at broadly the blockchain in the entire aviation ecosystem, both manned as well as the unmanned, UTM, ATM operations, digital thread and digital twin, safety and security related transactions, data storage and retrieval, especially for high bandwidth applications, and data interoperability aspects. This is the scope of this particular committee. As far as the organization structure is concerned, we have the chair. I lead this group. I'm from Infosys. Similarly, we have the vice chair is from the from Boeing. Robert Rencha, who is a senior systems engineer, who is the vice chair of this particular committee. We have Chris Marco, who is the assistant director from IATA. He is the secretary. Then Ronda Collins, who just spoke before me, she is the technical advisor of this particular committee. She is the founder chair of this particular committee. We have the SAE staff, Dorothy. She does a wonderful job in managing the technical committee activities. We formed this particular committee in 2018. If you look at the overall contributors of this particular committee, we have people from OEMs, Airbus, Boeing, GE, Rolls-Royce, NASA, and also RCMA helicopters division. We have Tier 1, Tier 2 suppliers from Collins Aerospace to Honeywell to Aero and Supersonic. We have the operators, Air France, KLM, Delta Airlines, US Army, and so on. We have the regulators on board, FAA, EASA. Then MRO service providers, part distributors, IT product and service providers, consulting firms, and standard organizations in academia. All the people are there on this particular committee. We need this diversity to bring different perspectives of the ecosystem in developing the standards. So that's a quick summary about the committee. I will just quickly walk you through the work that we are doing currently. Essentially, if you look at the overall, we have published 4 documents so far. Of course, this committee was formed in 2018, okay? And the first document, the AIR 6904 document, is all about the data interoperability, which talks about the rational considerations and framework for the data interoperability aspect for the health management within the aerospace ecosystem. In fact, this particular document we started in the IBHM committee, HM1 technical committee, and later moved this document under this umbrella. Then we have published AIR 7501. This particular document talks about the aircraft asset lifecycle and the digital data standards that are out there. It is more or less a kind of overview document, gives a kind of bird's eye view of all the digital data standards that are available today. And also we have published the ARP 6823, which is essentially the electronic transactions for aerospace systems, which is a kind of a cornerstone document and overview document. Then recently we published the ERP 6984, determination of costs and benefits from implementing a blockchain solution. These are the 4 documents that have been published. Of course, we have set a target of more or less 2 documents per year kind of a target that we have. And we are currently working on 3 other documents. The one is on the AIR 7356, which is essentially talks about the blockchain for US and advanced air mobility. Then we have AIR 7367, which is essentially the document on the digital thread in aircraft lifecycle management. Then we are also working on another document, AIR 7123. This is all about the electronic transactions release certificate. Okay. Out of these 3 documents, 1 document, the first one, blockchain for US and advanced air mobility, we are going to take it to ballot soon. And we are targeting this particular document by end of this year or early next year based on the approvals. Okay, so what I'll do is I'll quickly walk you through some of those documents, the rationale behind each one of them. As I said, AIR 6904 is all about the data interoperability aspects. Predominantly looking at the health management side of it, health management gets a lot of this operations data real time, which is a voluminous compared to the configuration data. So what are the typical considerations that we need to look at? And the framework on the data interoperability is all being studied here in this particular document, summarized it. This was sponsored by Martin, who is currently leading digital data standards steering group. Then this particular document, aircraft asset lifecycle and digital data standards. This is an overview document. In fact, we've studied all the digital data standards that are out there. In fact, there are many other organizations that are currently working on these digital data standards. ATA, now it's called A4A, and also IATA, AIRINC, and EuroCAA. There are many other organizations who developed these digital data standards. So this particular document summarizes all of those documents that are available there and provides a kind of bird's eye view of those documents and also how these documents are getting used in the entire aircraft lifecycle. Then this is the document that was sponsored by Ravi Rajamani, who is our well-wisher, who is the forefather, I would say, father of the standards here from India side. So he has sponsored this particular document. This is a cornerstone document, gives a kind of quick overview about the electronic transactions for aerospace systems, and also talks about the various committees that are currently working on the digital data standards development. Then the ARP 6984, this is determination of cost benefits analysis for the blockchain solution implementation. This is very, very important because most of the organization got stuck with some of the technology aspects, but they are not really looking at what is the kind of value that it can bring and the business benefits. How do you estimate the business benefits in implementing the blockchain solution? That's where this particular document targets and also gives a kind of good insight on what people should consider as far as the value lever is concerned in developing a blockchain solution. How do you determine the cost benefits? And then we are currently working on blockchain for unmanned aircraft systems. In fact, this particular document is being sponsored by Dinesh, who is one of the Aerospace Forum member. He is a very active member. And we have a good number of contributors for this particular document across the globe, both from the OEMs, whether it is the Boeing or the NASA or the Collins Aerospace and other organizations. We also have various research organizations like MIT Lincoln Laboratory and other people who have who are helping us. And this document is more or less complete now. It is going to go for the ballot soon. And similarly, we are currently working on the digital thread document, requirement specifications and framework of digital thread in aircraft data lifecycle management. This document is being sponsored by Sastri, one of my colleagues in Infosys. It is coming up very well, and definitely if anybody is interested to help us in this particular document, you're most welcome. Then the last but not the least document, we are working on the electronic authorized release certificate. This document is being sponsored by Dirk, who is from the KLM, because aircraft operator uses these authorized release certificate quite extensively, and that is the reason he has came forward to sponsor this particular document. So those are the documents that currently we are working on. Let me know if you want to help us in any of those documents. You can reach out. These are my coordinates. Thank you. Thanks a lot for this opportunity. Over to you, Satish.
Thank you, Dr. Ravi, for a wonderful talk. It's always pleasure hearing from you, and your thoughts and ideas, right? So it's always encouraging to hear from you. So if anybody has a question, please post it in the Q&A window, preferably, or even in chat window if you prefer so. Right now, I don't see any specific question. As we wait to get some questions here, Dr. Ravi, maybe just to get some more thoughts and ideas. So in this case, in the case of blockchain, right? So preserving data or storing data is very important, right? So how do you, what are some of the mechanisms that this data can be stored? Can you share some light on what industry is doing in terms of data storage?
Okay. No, I think that's a very good question, Satish. Thank you. So essentially, if you look at this entire data, right, these data can be shared across the databases that is out there, okay, across the globe. What we are doing, essentially putting a layer on top of these databases, okay, which can help in improving the traceability part of it, security part of it, so that you don't need to really worry about the data security, okay? Because this particular blockchain layer will take that particular authorization part of it and helps you mitigate the risk. And also some of the constraints that we have in terms of the GDPR and things like that, so that you may not be able to share the entire data across the continents and things like that. Okay, you can keep that databases in your data center, and you can loosely couple that whatever data that is required shared. It is only the transaction that is important. Transaction, and give a kind of reference from which database it is coming from. Okay, so that you can just trace that particular database and look at it, how that particular data is being, what is the data, what is the accuracy, authenticity, and things like that. But essentially, this particular thing, it sits on top of it. So there is no change as far as the database is concerned, but it is only the overarching layer that we are working here.
Nice, nice. Thanks, Dr. Ravi. I think we have time to take one more question.
Satish, there are questions on the chat window.
Right, yes. So let me. Yeah, so Dr. Ravi, here is one question from Karthik Srinivasan. What are the requirements for candidates who wish to contribute to standards development? Right.
Okay. No, that's a good question. Definitely, there are no prerequisite. Every one of us here are learning. You are learning together. You should be passionate. You should have time to contribute. Essentially, in the initial days, when you join a technical committee, it is only the learning from the experts, okay, who have worked in that particular area, who are trying to understand the space and what is important for the industry and things like that. So initially, once you sit along with those like-minded people, you can learn a lot, and post that you can contribute further. In the sense, whatever you learned, you can contribute back in terms of reviewing the document, providing the insight, and things like that. So in a way, there is no prerequisite as such. As long as you're a good aerospace engineer, you're most welcome to join. Okay, so it's a continuous process. The fact that I joined this particular committee is essentially I want to learn and contribute back to the industry. That's the only motive that I have. Not that I know many things and things like that. It is essentially I want to learn, understand, and contribute back to the industry. If you have that, you're most welcome.
Yeah, there are few more related questions, Dr. Ravi. So let me summarize, similar questions. Are there any, restrictions or limitations to participate for, software platform providers like IBM to participate?
Okay.
Right? Are the standards open for all? Anybody can come and contribute.
Yeah, so anybody can come and contribute. There is absolutely no problem, because what I have given you is a kind of overall standards that we have. 4 standards that we have published, 3 standards we are currently working on. And in a year, twice we meet and deliberate on the current standards, the current progress that are out there, and also what are the standards as a team that we want to develop. Okay, identify the gaps and putting together a kind of rational, initially a kind of abstract kind of thing, so that the team is clear what is that they are going to work, and form a team, and that team will continue to develop or enrich that particular document as they meet and discuss regularly. So that's how the entire process happens.
Exactly. Yeah, it's open for everyone. Right?
Yeah, thank you.
So one more question. I think we have a few more minutes before the next talk. So Dr. Ravi, can we take one more question?
Sure, Satish.
So a question from Kumaresh Jaiprakash. Enabling blockchain onto supply chain of aero engine parts, how far this is feasible? Can you suggest, approximately how long does it take, to incorporate something like this into the supply chain?
Okay, no, in fact, there are certain blockchain solutions already existing as far as the supply chain is concerned. In fact, my colleague who is there, Mike, can give some of the work that SAE ITC is working on. More specifically, some of these parts, standardization part of it, and onboarding the part or a component supplier onto the blockchain. So it is there. And some of the organizations, they're already productionized some of these blockchains. Okay, and so in one way or the other, supply chain and the part traceability is fairly matured as far as the blockchain adoption is concerned. And what my belief is, in a matter of 4 to 5 months, you can roll out a typical blockchain network. And of course, you need to have that the business case and the technology thing, whom you are targeting and things like that. But typically a matter of 4 to 6 months is a good time for creating a blockchain solution.
Sure. Thank you. So there is one question from Ashwin, especially talking about AI-based approaches. So I will take this particular question, Dr. Ravi. Reason being, we do have a dedicated talk on this. So we have a talk focusing on AI in aviation. So just stay tuned for a few more minutes. So today, we have that talk in this track itself. So stay tuned for some time. I think in the interest of time, still, Dr. Ravi, I still see a lot of questions pouring in.
Sure.
Probably, we will address these questions offline if that's okay with you.
Perfect. I think we will just collate all of them, and then do reach out to me in case if you have any other details or any other information that you want to know. And definitely we need your help. That is one of the important aims of this particular workshop, so that everybody is aware of it, and together we can work for this wonderful industry.
Thank you, Dr. Ravi, once again.
Thank you.
So now let's move on to the next topic. And for that, let me introduce Christopher Sandberg to talk about G32 Cyber Physical Systems Security Committee. Christopher Sandberg is a product cybersecurity engineer at Woodward. And Mr. Sandberg is responsible for security architecture, secure development lifecycle, and product security compliance across a wide variety of cyber physical devices sold by Woodward. Mr. Sandberg's work history spans over 30 years, concentrating on wireless communication and embedded systems development. Background includes cyber physical systems, industrial control networks, vehicle networking, and emerging digital technologies such as artificial intelligence and cloud architectures, IIoT. Mr. Sandberg has actively participated in the development of SAE G32 Cyber Physical Systems Security Standard, serving on the software assurance subgroup. So with that, Christopher, welcome, and over to you for the talk.
Yep, my name is Christopher Sandberg, and today we're going to go and have an overview of our SAE G32 Cyber Physical Systems Committee. I'm really happy to present, and thanks for that excellent introduction. So we have a lot to cover. Cyber physical systems are very important in a lot of the industries we deal with, industrial, aircraft, as well as automotive. So it's a very pertinent topic, especially around system security. I'm going to go over to this morning roughly what is the SAE G32 committee, why does it exist, what problems we're trying to address, and then we'll go over what are the subcommittees are involved. So we're going to have our domains of consideration discussion. We're going to talk about hardware assurance, software and firmware assurance, risk, as well as how are we going to tie all this stuff together. And the tie together for us was really around EV charging, because that's a pertinent topic, as well as something that we can all look very green about. So what is SAE G32? SAE G32 is really around cyber physical systems, and how is that exactly different from traditional cybersecurity? We also want to look at kind of what's the awareness of the threats, what are examples of threats, impact on those threats, what we're trying to address, as well as very high-level objectives in the System Security Committee. Come on, PowerPoint. Okay, here we go. So what is different than traditional cybersecurity? So as we kind of know, cybersecurity, as we've classically come to recognize it, are measures taken to protect a computer or computer system, as on the internet, against unauthorized attack. Cyber physical system security, however, are risks that come from threats that can exploit weaknesses and vulnerability in cyber physical systems with the integration of complex hardware, software, as well as firmware. These vulnerabilities really kind of drive that establishment of the area of cyber physical system security. Proactive and coordinated efforts are needed to provide security and resilience for cyber physical systems. The SAE G32 community charter is basically defined as this. We are rolled up under the SAE Aerospace Council, as our previous speaker kind of showed where G32 lies. The scope is through this committee, the SAE Aerospace Council's authority. Its documents are intended for broad industry use, commercial defense, other high reliability and/or critical systems in aerospace, transportation, medical, and industrial, etc. The objectives around SAE G32 are really to coordinate the knowledge, experience, and skills in cyber physical system security, to assess vulnerabilities, recommend system engineering focused mitigation actions, share knowledge of how vulnerabilities are introduced and exploited in cyber physical systems, document best practices for addressing areas of concern utilizing existing processes, procedures, and standards, develop a taxonomy for cyber physical system security, establish standard methods for identifying vulnerabilities in cyber physical systems introduced at any point in the cyber physical systems security engineering lifecycle, and mitigating those impacts, and then develop validation and verification methods to ensure those requirements are addressed. As you can see here, we have a kind of a house view of what exactly does cyber physical system security and engineering really maintain or apply. And if you look at our base area, electronic part, the components are used to build up our cyber physical systems. On the top of those components, we're going to layer software, firmware. We're also going to have hardware that may have firmware on board it, such as systems on a chip, chiclets, those other types of items. And then these all tie together in a cyber physical system. That cyber physical system is a component like an IoT device, a engine controller on a car, or on an aircraft, just a wide variety of different types of applications. The system integration is a relatively novel concept here. We're really talking about how we're going to combine all these cyber physical systems into a cohesive systems, and what are some of the issues we're going to run into that. And this all ends up getting protected by cyber system safety and cybersecurity. So from a high level perspective in a cyber physical system, how does security mitigations, defenses in depth, that type of stuff protect the cyber physical system from attacks or from exploits and weaknesses? When we talk about cyber physical systems, I think we're all familiar with all these items in this list. We're really concentrating on how all these items actually contain these types of cyber physical systems, the components that go on the board, the chips that go inside these devices, the software that's used to actually run these devices. All these can introduce weaknesses, vulnerabilities that could be exploited by attackers, and we have to figure out how to mitigate those risks in those cyber physical systems. What are some of the examples of contemporary threats that we've had? Well, we've had the SolarWinds Orion supply chain attack from earlier this year, which involved getting into a trusted provider of network monitoring, getting into their build system, putting in code that would impact or exfiltrate data, maybe do some reconnaissance, and then actually distribute it as a signed piece of software. Hafnium is another good example. Earlier in March, Microsoft really kind of detected some issues with on-premise Exchange servers. This was enabled people to get into Exchange servers at a local client or a local company, put in what's called a web shell, exfiltrate data from that, and then pivot for further attacks. Another example here in the United States, Colonial Pipeline. That was a relatively big ransomware issue way back in May. What was interesting about this is the cyber physical systems weren't immediately impacted. However, IT systems that handle the billing prevented that product from actually flowing in the pipeline. So it was a kind of a indirect attack against a cyber physical system that prevented a disruption of service from actually happening. And then finally, earlier this summer, we had the CASIA VSA. So CASIA is a tool used by managed service providers to monitor customers' cybersecurity in a network. And basically, this actually only impacted about a dozen initial installations, but ended up impacting 1,000 to 1,500 organizations that were customers of these managed service providers. The actual ransomware demand was about $5 million per site. The company or the ransomware group that was actually doing this offered a universal decryptor for $70 million. And it turns out that they were this decryptor magically appeared after a couple of weeks. In software itself, I think we're all familiar with OpenSSL. That's a popular open source package. It's a volunteer-driven collaborative software development environment. It's used to secure our SSL and TLS protocols in the internet. Here we have quite a few vulnerabilities that do appear in these open source packages, and how do we mitigate and handle risk around that? In the supply chain attack, Ripple 20, which was a TCP/IP vulnerability stack in the supply chain, and both Ripple 20 and Amnesia 33, if you look at them, actually kind of could be several layers down from a purchased RTOS or a purchased system component that you're actually using in your cyber physical product. So how do we identify those kinds of vulnerabilities? And we're going to get into that here on the documentation in kind of the targets of our standard. Finally, Codesys. Codesys is popular in industrial control circles as a framework to develop cyber physical systems with. However, inside that framework, there's been a number of vulnerabilities that have been identified. And again, these are vulnerabilities that may be impacted by a number of manufacturers in the software supply chain. On the hardware side, hardware is not, we all say we can fix it in software. Well, hardware is also vulnerable to security vulnerabilities as well. So here we have like an authentication bypass in a remote code execution in an EV charging station with FPGA issues that are going to impact our cryptography and protection of FPGA devices. iPhones, well, actually these aren't iPhones, but this was actually an example of a modem that's inside its popular phone, the Snapdragon chip that's used by Qualcomm. They had a vulnerability in there that allowed a lot of remote code execution to get into the phone. And finally, Apple can't be immune to this. They have a brand new chip out, that M1 chip that's in a lot of popular PowerBooks. There's a security flaw that came out in a brand new chip. So these things happen. How do we have an assurance case that's going to handle that and provide security for cyber physical systems? There's one more piece of this we want to talk about, and we talk about a lot of contemporary threats that may in the news. However, some of this stuff is actually kind of obscure. So dope and Trojans. This is basically a type of Trojan that can be implemented into an FPGA area by just simply changing polarity during operation. Another good example here is how to hack an aircraft. This is way back in 2008 when there was a crash of a Spanair flight. The central computer system that was designed to monitor technical problems was infected with malware. Whether it actually directly contributed to that crash kind of remains to be seen, but it was part of that investigation. And then finally, pro-ASIC hacking. How do you hack ASICs, which are derived chips? There are ways to do this as well. So, all this comes to say is that, in software, hardware, firmware, we have security issues, and how are we going to assure those when they're used in critical applications? So G32 is really, again, going to interact with multiple organizations, and our committee is actually made up of representatives from all these organizations to help handle that cyber physical system security in the ecosystem. So here's a good example. We're typically here in the vehicle area, but we also have to talk to infrastructure and critical infrastructure. Medical devices are impacted by cyber physical systems. Banking and finance. This is something that not a lot of people consider as part of a cyber physical systems ecosystem, but they're the ones that enable a lot of functionality, especially when we start talking about billing, charging, that type of stuff. Position, navigation, and timing, artificial intelligence, all this stuff is really impacted by G32's work in the cyber physical system security standards area. From an overall large perspective, we kind of have this excellent triangle view that kind of wraps up what we're trying to accomplish here in G32. So Core to our beliefs are several domains of consideration. We commonly call this the pinwheel, and I realize it is quite small to read, but don't worry, the next slide we're going to kind of blow that up, and you can see the 16 domains of consideration. Kind of a very large tenet of this is risk mitigation. We do a lot of focusing on risk analysis, risk mitigation techniques in hardware and software in cyber physical systems. There's a lot of documentation that's out there. However, we're really focused on specifically concentrating cyber physical systems and putting in novel risk management techniques to handle some of these issues that before they get out there into production. Finally, down below, we have electronics, hardware, and firmware, and software. These are the core tenets. More often than not, in a product development lifecycle, your hardware is going to be there for a very long time. Software, we always say that we can fix things in software. We can provide mitigations, we can provide defense in depth, but we can't fix broken hardware. So how are we going to handle this in the future when we have very long life software, hardware components out there, but then we find that there's vulnerabilities in place? So this is kind of the standards guidance that we're trying to provide in G32 for those industries. So as promised, here's our domains of consideration. These are 16 different areas that we've identified in the G32 Standards Committee, really kind of around what we're going to tackle in this standard. And they range all the way from electronic security all the way down to information sharing and reporting. You can see a lot of anti-tampering, anti-malicious behavior in here, but we also talk quite a bit about lifecycle support, obsolescence, and cyber supply chain risk management. These issues are huge right now, especially with the pandemic, because the pandemic's really driven pressure on the supply chain. So we have chip shortages, we have components are being end of lifed considerably earlier in the life cycle than we initially thought they would. So the need for this document is huge right now. And then, kind of tying everything together with the past couple of slides, here we have our classic system V diagram kind of in the center. The V diagram here really kind of provides that foundational reference material to other standards like 15288 and the NIST SP 800-160 around system engineering development. And then really overlaying kind of our threats, vulnerabilities, weaknesses, security requirements that we need to address in the typical systems development lifecycle. This application, the application of the G32 standard is really around the lifecycle. So commonly we see a lot of standards that come out that are really product development standards or development standards that really take place kind of in the left-hand side of the V. We've identified that a lot of these cyber physical systems are going to be out there for a very long time, so we have to address issues throughout the whole life cycle. So that gives us the concept of what we call triggering events. What happens out in the field when a vulnerability hits a component or control, and how does that kind of flow back into the system development lifecycle process in the form of patch updates, additional security requirements, or even looking at our hardware and figuring out when do we need to start targeting a hardware check refresh or a hardware update to resolve some security issues. So how do we approach this? It's a very complex topic, as you can see, and there's a lot of information that we have to absorb, plus a lot of guidance we can give our software systems engineering. Well, if you look at kind of our classic, we call this the stool diagram, but cyber physical system security is really built up of supporting operations. So we have systems engineering as a really big part of that. We also have guidance we need to provide in software assurance as well as hardware assurance. Both are complex topics and both can actually kind of stand on their own, but they feed into that cyber physical system security from those component types of perspective. How's this document going to be structured? Well, our main document, which we're currently resolving ballots or comments on from our ballot that we actually published back in January of 2021, is JA 7496. It's a joint standard, so it's applicable to both aerospace and ground vehicles. This is the Cyber Physical Systems Security Engineering Plan. So this will be our main keystone document. And inside this document, we actually have a couple of informative appendices that help illustrate some of the concepts in cyber physical system security. So we really took that concept of the systems engineering V and applied it to cyber physical systems engineering. Again, using 15288 as a very good base for it. We have an extensive group in risk management that have actually contributed a very handy informative appendix about how to apply risk management into cyber physical systems and cyber physical systems engineering. And then finally, we have an illustrative example subgroup. And these guys are really the ones that are taking the concepts and the core information that we've put into JA 7496 and apply it in a practical sense to walk through the practitioners about how would you actually use this standard out in the production world or out in the physical world. Down below, we have two separate documents that are going to feed into this main document that are currently under development. We have a hardware assurance document, JA 6801. This is really putting together an assurance case, and we'll walk through what that document looks like here in a few minutes. On hardware assurance, hardware security, from the component manufacturing capability level, and kind of walking through what was an assurance case look like. The other document is software assurance, and this is JA 6678. And really, this is kind of the hardware, the assurance case for software. And the reason why we kind of separate these documents is there's unique needs in hardware that need to be addressed. In software, it's going to be a little more rapid, a little more iteration. Again, software fixes everything. So really briefly, what does our committee look like? Right now, we have about 310 total participants, and as you can see, it's a very wide mix of industry for a very good consensus. So we have quite a bit of aerospace and ground vehicle representation, but we also have a few government and consultants as well. And we can't forget IT. We're dealing with the OT, we're dealing with control systems that don't always interact with IT, but IT kind of is what makes us click sometimes from a threats perspective. Okay, so going into hardware assurance, this is kind of this is going to be a really brief view of what we're trying to tackle inside that hardware assurance area. So this is kind of that whole life cycle of from all the way from designing to sustainment to getting it out in the field. These are all the kind of assessments we need to run at each part of those as the life cycle progresses when we start receiving hardware. Finally, at the very bottom here, we have custom integrated circuits. We have off-the-shelf chips we can buy, and we have certified type chips that we can also bring in. So we're really trying to address that assurance case throughout the whole life cycle of the integrated circuit or the component we're trying to apply hardware security to. We're really working from the bottom up, making sure that the lower pieces of that hardware component definitely have security built into them and meet security requirements that we're specifying. But we also have these top-down requirements from projects that have to kind of meet in the middle at some point. And then finally, we have to verify that the system requirements assurance case is really, from a stakeholder's perspective, adequate, and they can accept them. Stakeholders in this case are going to be all the way from our OEM top tier groups to government agencies to suppliers, much like my company, Woodward, that are kind of stuck in the middle, that we have to talk to OEMs, and we have to talk to sub-tier suppliers as well to verify that these items are secure. And finally, there's a wealth of knowledge out there around leveraging existing resources and standards. And this is just a good example of how SAE can kind of be that middle road in there in taking what's already out there, applying what we need to address for a specific topic, and then releasing it as a standard that can be used by other companies to audit out of kind of their supply chain. So some of the hardware challenges that we're running into, who do we actually target this to? Do we target to chip manufacturers? Do we target it to suppliers? That's why we have a wide variety of subject matter expertise in the committee. There are other standards out there, but they're not really addressing this type of stuff. And we got coordination with definitely related efforts from NIST and other groups that are helping out. The assurance case that we talk about really briefly, hardware assurance is really kind of basing that off of ISO 15026-2 for its data structure. So basically that says we're going to have a claim, an assurance claim that's satisfying a typical assurance level. And you kind of work backwards through that as far as vulnerabilities, weaknesses, that type of stuff that may exist. So finally, when you kind of get back all the way to the left, you can leverage other types of standards, leverage other types of information to really substantiate that assurance claim. Hello?
Me.
Okay, so that was the hardware assurance piece of it. Next up, we're going to talk about 6678, and this is the software assurance standard. So this is again really kind of applying a risk framework around software assurance and providing risk assessments. We also provide quite a bit of information around verification of those risk assumptions that we are making. So as you can kind of see, again, it's kind of this life cycle application of it, where we are framing the risk in a context or scope of where that software or where that component's going to be used, taking part in a risk assessment, then actually doing the software development around those risks that we've identified and security requirements we have to incorporate, and then monitor as it's out there in its life cycle. And this is kind of that risk assessment framework. We're definitely basing it off of SP 800-39. It's a great wealth of knowledge. But this is really targeting cyber physical systems. So this is specialized in this area and feeds back into development risk, organizational risk, that type of stuff. I know we've talked a lot about risk, so we're going to really briefly talk about what that risk appendix looks like. So this is the what versus the how of risk. So as you can see, we have that systems V process on the left, which we're talking about what is risk that's inside that engineering process. On the right side, we're talking, we talk about how. So how are we going to address risk? How do we provide guidance for cyber physical systems practitioners to address that type of risk? And this part of the document is actually a few pages long, but it provides a great wealth of information around that risk. So the risk analysis process is used especially in triggering events where we have lifecycle items that happen, system obsolescence, system component obsolescence, vulnerabilities are found out in the field, new and novel ways to attack something. Those are all types of triggering events where we have to kind of go through a risk scenario, what are the consequences, score that, and determine what our mitigations are going to be. Those mitigations could include a software patch, they could include maybe a firmware patch, or even a recall of the device. In the illustrative example, and this is a pretty good picture of kind of all the components that are involved when we talk about charging and stuff like that. We really want to take all the technical processes from the system V from 7496, take that risk management framework that we illustrate inside the appendix, and finally, how does that tie into those domains of consideration? So this is kind of the whiteboard we're dealing with in the illustrative example, but we really kind of tie how all these are put together. So we have an electric vehicle at a charging station that integrates with a charging app that's on a cell phone. And then that talks to backend services where we have a charge management server to enable that charging. But then we have to bill for it. So there's our financial component as well as other application pieces of it. We have to talk to the utility about how to bill for that charging actually takes place. Do we have enough power on the grid to actually supply that? do we need to pull in a DER, a distributed energy resource, in order to augment some of that green energy? So as you can see, there's just a wealth of different areas that cyber physical systems impacts in an electrical vehicle charging application. And this is just a very high level touch of what exactly that looks like. And this kind of illustrates kind of what some of those key critical data points are in that illustrative example. So finally, tying it all together, we have several spaces in the illustrative example where we're actually going to provide videos, help, and documentation around how to apply G32's standards framework into a typical cyber physical system. So we adopt the technical processes, we apply the risk management framework, we utilize those domains of considerations about how they impact the cyber physical systems. When do we update standards and designs, and then how do we respond to triggering events that take place in the life cycle of the cyber physical system? And with that, that's the end of the presentation. So I will open it up for questions if we have time.
Yeah, so maybe we can take one question, Mr. Sandberg. Right, so
okay.
Yes, there is one question from Madan Mohan. Is risk analysis similar to threat modeling in software systems? So how do we see that? How do we understand that point?
That's a really good question. So threat modeling is actually kind of the integral to risk analysis. So you have to take into account it's kind of a component of risk analysis, if you will. Threat modeling really kind of comes into play where you're identifying the interfaces that are going to interact. You're going to identify threats and vulnerabilities that may try to act upon that interface, and then you have to identify kind of that risk of how that works. And that risk is that its consequence, likelihood of it, and impact all kind of feed into how are you going to triage, or are you going to create new security requirements? Are you going to rely on countermeasures upstream?
Right. Yeah, I don't see any other question here right now. So there is a comment, but it's not a question, so maybe we can leave that.
Okay.
So maybe yeah, with that, so we will close this session here. Thank you, Mr. Sandberg. It's a wonderful session. Great to hear various activities and initiatives G32 is driving. Thank you so much.
Thanks, Satish.
Now let's move on to the next session. Now I'm glad to invite Mark Robo to talk about G34 or EuroCAE Working Group 114, which is Artificial Intelligence in Aviation Committee. Mark Roboff is CEO of Skythread, a new venture building the future of digital connectivity for the aviation industry. Mark has over 15 years of experience in aviation digital transformation, both as software engineer and as a business and technology executive. Mark is recognized thought leader in artificial intelligence and machine learning, as well as MRO data, processes, and analytics. Mark has worked and contributed to many of the industry's largest digital MRO platforms, and he has also worked with dozens of airlines across the globe on prognostics, predictive maintenance, and optimization of maintenance execution. Mark is also the chair of SAE G34, EuroCAE Working Group 114, a joint international committee for artificial intelligence in aviation. Mark is member on the SAE G31 Electronic Data Transactions Committee, S18 System Safety Committee, and the Digital and Data Steering Committee. And is also a member of the Prognostics and Health Management Society. With that, Mark, I hand it over to you for your talk.
Thank you, Satish. And hello, everybody. Good morning, good afternoon, good evening, depending on where you are in the world. Mark Roboff, thank you for the kind introduction. I'm going to share my screen. I'm going to share a couple of slides. Unfortunately, I have a hard
is the voice break only for me or for?
Yeah,
bottom
Mark, your
of
voice
the
is not clear.
hour.
It's for everyone. I think
Okay.
I'm not able to
Mark,
hear it properly. Yeah.
Mark, sorry to interrupt you. We are getting
Yeah.
some breaks in your voice.
All right. Hold on one second. Give me one moment. All right. Is this better?
Mark?
So I'm going to go through relatively brief.
No,
Any better?
I still see audio issues.
I don't know if I'll have
Yeah,
time
we're not able to hear
for
him.
Q&A, but certainly after in the chat can be follow up.
Mark, we're not able to hear you.
Now, better?
Can you please check if you are on mute or?
Can you hear? All right. How about now?
He's not on mute. I think it's a
Yeah, he's not on mute,
speed
but I
issue.
think there is some
Good idea.
connectivity
Mark
issue.
can cut
Right.
off the video and share only the slides.
I think,
Yeah, Mark, it's okay. Maybe we can try by turning off your video and just try voice mode.
How about now? Is this any better?
This is much better, Mark. Yeah.
Much better. Okay. All right. I'm going to go ahead and again share my screen. All right. So as Satish mentioned, I am the chair of SAE G34/EuroK Working Group 114. We're a joint international committee focused on building a process standard to become the accepted means of compliance for the certification of safety critical AI in airborne and ground-based systems. So what this is all about is revolutionizing complex systems development and creating a path to certification for those type of applications that we expect will either benefit from AI ML running in, say, the avionics stack or in the air traffic control stack, or for those applications where we expect AI and ML would be a critical requirement, such as for autonomous flight. So G34 is comprised of over 500 members. That's aerospace engineers and research scientists, technical fellows, certification experts, even a few business development executives from across the global aerospace and aviation community. It's Boeing and Airbus and Embraer. It's the engine makers, it's all the avionics manufacturers, it's the defense companies like Lockheed and BAE and Northrop. It's also a couple of airlines are engaged, from Air France KLM to FedEx to Lufthansa. Also, we have many of the world's air traffic control providers, of course, the FAA in the United States, but also DFS in Germany and NATS in the UK, Eurocontrol. We have great support from the global regulatory community, the FAA and EASA and Transport Canada and ANAC and civil aviation authorities in the Asia Pacific region, and of course, ICAO. And we are working on a process standard for the development and certification of AI ML and safety critical systems. And this standard is going to be is due to be released by this time next year. In support of that, we have released already an AIR, which is a gap analysis against current standards, detailing why you can't leverage current standards like ARP 4754 or DO 178C to certify AI. And it's a statement of concerns, is what needs, outlining what needs to be addressed in order to put together a framework that will allow for the demonstration of a safe and trustworthy system, such that it can be certified. The committee is split into 6 working groups. SG1 is focused on use cases and on managing differences between a standard that would be applied for airborne systems versus a standard that would be applied for ground-based systems. SG2, SG3, and SG4 then take each a critical component of a machine learning development process or phase. So for instance, SG2 is focused on concerns around data assurance. How do you manage data that you gather? How do you validate that the data you have is precisely the data you need to build a safe and performant system? SG3 is focused on the design of the ML system. So what algorithms are to be considered, what performance requirements are to be considered around the execution of an AI or ML development lifecycle. And then how do you verify what you've built in like the digital environment? And then SG4 is once you have a performing ML solution, how do you then implement that into a broader aerospace system? So it's how do you implement that into a more traditional avionics technical stack, or ground-based safety critical technical stack. SG5 is then focused on system and safety considerations across the life cycle. And we have a new SG7. It's not on this chart. SG7 is focused on process considerations and leveling for certification. So what that means is, do we leverage the same design assurance level classification that is standard today via DO 178C and ARP 4754 and like documents? Or do we go and devise something unique for AI and ML considerations? That's what that subgroup is building out. In addition to the statement of concerns document, there are a couple of other documents that are in the pipeline to be released, including a document that outlines use cases for AI and ML in the safety critical domain, as well as a document that expounds on the taxonomy that we've adopted in the committee that defines what we think of as AI and ML and what we're focused on in terms of problems we are solving. The broad landscape that we're working towards is supported by a number of released publications that outline both a roadmap and a gap analysis for the acceptance and the certification of ML systems. Chief among these is a document released by EASA, the European Aviation Safety Administration, in January of 2020, called the EASA AI Roadmap. The AI Roadmap is, for us, an orienting document. It is actually quite easy to read and understand, and it outlines exactly what we need to solve for in terms of devising a framework for demonstrating that an AI system is safe and performant, right, and thus can be certified. In this roadmap, EASA outlines a timeline for what they see as the certification of AI and ML and safety critical systems. We are working very vigorously towards that timeline, which calls for the first component to be certified by 2025, effectively in 4 years, right? Our standard, or at least the first version of our standard, is due to be released in the spring, summer of next year. Will hopefully be shortly recognized as an accepted means of compliance soon after, supporting that 2025 deadline. If we then expand 5 years after to 2030, EASA imagines that by this time, we'll have a means to certify single pilot operation of a large transport aircraft. By 2035, right, we'll have the means to certify zero pilot operation of a large transport aircraft. And note that while EASA talks about Part 25 large transport aircraft, i.e. airliners, in this roadmap, they envision, as do we in our committee, a single standard that encompasses all of aviation, from legacy airliners to this burgeoning field of air taxis and drones and whatever else you want to make of that. So the other documents that have been released in time include, for instance, a critical analysis on ML systems in aviation by AVSI, as well as an ANSI UAS standardization roadmap. Most recently, the EASA has released what they call the concept guidance level, the level 1 concept guidance for machine learning. So what that document does is expounds further on the AI roadmap they released a year ago, and outlines a lot of the work that we're doing in demonstrating, well, what does learning assurance look like? So again, we have the standard to be issued next year. That standard, by the way, is going to be focused primarily, actually exclusively on what we'd call offline learning, right? So here you have a machine learning built element where the learning happens offline in a development environment. Once that model, that machine learned system, that we call it machine learned model, is built, it is going to be then effectively frozen and then integrated into a more traditional avionics or safety critical system stack. And then it will be managed under traditional configuration and version management schemes. After the release of the standard and after some maturation of the topic space in the industry, we anticipate later in the decade working on a next generation of the standard that would focus on online learning. Online learning is a capability that would require a complete rethink of how we do versioning, maintenance, configuration management, and leveling. We'll take that once the industry is comfortable with machine learning certification in its most simplest cases. It is very much a one step at a time affair. This is a high-level view of how we anticipate changes to a standard V&V workflow. So one of the things that we are working on, again, with the regulator community is reimagining what a development lifecycle looks like with AI and ML in the middle. So most aerospace engineers today are familiar with the concept of validation and verification. Requirements are validated, systems are built, and then that system is verified against the validated requirements. With ML, we understand there's going to be a shift in that process. EASA is big on positing instead of a V, having a W, where the outer edges of that W point to classical requirements gathering and validation and implementation of an ML system in a classical avionics stack that then goes through classical verification techniques. The middle part of that W is designed to run iteratively, where data is gathered to train a system. That system, they call it a system or that model, is then tested for its performance in meeting the requirements, right? If performance is not met, right, then different data is gathered or different algorithms are deployed, and the test, the verification is repeated until performance measurements are met, right? So we can imagine in the middle part of that W moving to a more agile, repetitive, and iterative development environment. And that's possible because in an AI ML world, all of this happens virtually on digital systems. And thus, cost and time is much less of a consideration than if we were developing in purely a traditional manner. Long-term vision is how do we get from where we are now looking at modifications to the verification and validation or validation verification lifecycle. to how we get to certify AI and ML, what we recognize is that over the long term, what we're really going to be focused on, what we're going to really have to achieve, is a rethink of the architecture of certification. So today, there's one process that's well established to certify product, and there's a separate process well established to certify people, right, in an aviation ecosystem. What we imagine with AI is a merger of these two processes. So for instance, when we think about what is the chief challenge or the chief construct we're trying to solve for in building an accepted means of compliance to the certification of AI and ML, it's really about the explainability factor. How can we explain that an ML system is doing what it should be doing, right? And if we were to think about applying traditional assurance methodology, particularly that comes out of DO 178C, being able to take requirements and apply traceability coverage, right? Being able to say how every line of source code implements a functional and performance and our safety requirements. We can't do that in ML because we're not writing source code. We're giving data to a system, applying an algorithm that basically says, take this data and figure out what to do with it, right? The resulting code we get, if we can call it that, isn't decipherable. It isn't logically decomposable to the way that we would normally think about and construct source code. Therefore, the constructs of traceability and coverage that we leverage in traditional software certification don't work. This is an element. This is an element of the explainability issue that we're really here trying to tackle. So at a high level, right, how do we solve for this problem? Well, one thing we can recognize is that we've already solved for this problem when we think about how we certify pilots, right? So imagine trying to certify a pilot like you certify avionics software, right? When you take that pilot out on a check ride, are you putting diodes on that pilot's head to measure the neurons and the synapses that fire in that pilot's brain, right? That's the sort of the human concept of doing traceability. And of course, we don't do that because we have no idea how to connect the physical chemical reactions of neurons firing in the brain to how we think about and analyze and act in our Gestalt understanding of the world. And that disconnect exists with ML. That's the explainability problem in a nutshell. We can have a system do something by training a neural network, but we don't understand how the structure of that trained neural network translates into the logical decomposition of what our system is doing. So, how do we get around this in the human context? Well, we have flight schools, right? We know that we can train a pilot. We know that how to train a pilot well determines on what we're giving the pilot to learn and what we're giving the pilot to do and learning how to fly an airplane. And then ultimately, and this is the critical piece, right? Once that pilot's gone through flight school, we take that pilot out on a check ride and judge whether or not that pilot is able to fly their airplane safely and competently. And that check ride can be adopted along with the concept of the ground school to a virtual environment and be given to AI systems. So imagine, how will we train an artificial pilot? We bring that artificial pilot down to a ground school, a digital ground school, if you will, creating what is the correct curriculum to train an artificial pilot. That's exactly what EASA and G34 and the FAA and Euro K114, that's what we're all trying to solve for in creating data assurance, learning assurance. How do we know that the data we have to train the model is the right data? Then there's the concept of the check ride, right? How do we verify that the artificial AI autopilot we've built works well? Well, that's where simulation comes in. So one of the key questions that we have to discover next and determine next is if we're going to build a simulation environment, right, that is going to basically be the environment in which an AI system takes its AI check ride, what are the performance and the robustness requirements of that simulation environment so that we can trust it as a true facsimile for real life. And there's some interesting questions there. This has us looking at, particularly in the US context, FAR Part 60, right? So the part of the federal air regulations that concern flight simulators, right? And here's an interesting question, right? So today, when we look at the most robust flight simulators, motion flight simulators, what we call level D flight simulator, used for pilot currency. Those are the types of flight simulators that companies like CAE and Thales build. Right? There is a performance requirement on the on how fast, right, the virtual environment updates, which effectively is 10 frames a second. Well, we can imagine building vision systems into an AI that perceive the world as we do, cameras and image recognition, like we see today in Tesla autopilots. Well, is 10 frames a second enough to have those systems both learn and respond quickly enough? When we look at human conditions, usually in order to get a very smooth simulation of the real world, you need to be operating at 60 frames a second, not 10. So, what are the performance requirements for a flight simulator that can serve as a virtual verification for AI systems? It's a critical question. And that's a question, again, that G34 is tackling, but it's going to be tackling in conjunction with a new SAE committee that was just launched in the last month called G35. G35 is looking at simulation and its role in model-based engineering and its role in the certification of AI systems. And what that committee is trying to do with us, and this is part of the overall framework here, is to have a revolution and very much, I'd say, a reorganization of how engineers engineer airplanes. Today, when we think of the cost of developing a new platform, right, whether that be a new airliner, maybe a new fighter jet, or a new air taxi, if we will, right? We know that the cost of developing that platform is going to be measured in the billions of dollars. There may be some debate, depending upon the platform, if it's going to be in the tens of billions of dollars, or the 50s of billions of dollars, or the hundreds of billions of dollars. But we know the cost of that's going to be in the billions of dollars. What we will be able to accomplish, right? And I think the reason for doing this, beyond creating autonomous flight and all sorts of exciting new use cases and systems in aviation, is that we will be able to shrink dramatically the cost of aerospace systems development, taking things that are done today in the physical world and through model-based engineering and AI and ML development and flight simulation, transfer them over to the virtual world. Take cost out of flight testing, because now flight tests can be done virtually. Take cost out of requirements gathering, because requirements gathering can now be done iteratively and faster, while at the same time, not simply maintaining the level of safety that we enjoy and work to uphold in this industry, but improving that level of safety. So I'll close with this, right? Why, we talk about AI pilots, we talk about AI systems, we talk about moving the physical to the virtual. What's the purpose? Certainly cost is something to consider. If we're able to reduce the delta of cost from a DAL A systems development to, say, a DAL C or D systems development down to zero, then we open the floodgates for innovation in this industry. I can't even imagine what new systems and new developments entirely new entrants will be able to build and bring to market in this industry 10, 15, 20 years from now. But in a traditional context, when we think about, well, would we ever want, right, an AI flying our 737 or our A320? I'll point out that if you look across the vast majority of accidents and incidents over the last 20 years, particularly the most famous ones, right, you can make a very strong argument that an AI system would have avoided the accident. And I'll use one example just to close. We all remember, I guess it was 11 years ago now, right? The miracle on the Hudson River. It's that A320 that took off from LaGuardia Airport in New York City, had a bird strike, both engines lost power, and landed safely in the Hudson River with all lives saved. Question I'm always asked is, would an AI system be creative enough in that same circumstance to land in the Hudson River? And I actually do think the answer is yes, right? But beyond the answer being yes, an AI would be creative enough to do that if necessary. The more important point is that the AI wouldn't have to, right? An AI, right? The value of machine learning in critical decision making, in executable function like piloting an airplane, is that you can merge executable function and analysis in the domain of what humans have been doing, in this space over the last 80 years, with the speed of computation. We can shorten what we'd call the OODA loop, right? Which calls for how pilots evaluate and respond and act in any given situation iteratively. It took 7 seconds for the Miracle on the Hudson flight to recognize what had happened and decide on course of action. An AI system flying that as an airplane might have been able to react in 1 second or in 500 milliseconds. And in shaving off those 6 to 6.5 seconds, it would have had time to land at LaGuardia, right? And that's the point. We believe that NL is not simply here to replace human function, but to make aviation, right, that stepwise level safer. All right, well, that's my presentation. Again, I'm a little bit over time and I have a hard stop, so I thank you all. And I guess if there are questions in chat, Ravi or Satish can send them to me offline.
Definitely, Mark. Thank you so much for the wonderful presentation. And I got a lot of insights, really. I learned, a couple of things to understand how AI is going to impact, and what are various concerns related to using AI in aviation and aerospace industry, right? So thank you, Mark. I know you had a hard deadline, hard cutoff, and you had other commitment. Thank you, for extending your time and being available here in this conference. Thank you so much.
Thank you.
So how are we doing on other track? So that brings us to the end of this track. Hassan, anybody from SAE, how are we doing on other track? We are on dot now. It's 8:15. So we should actually thank all the speakers, for sticking to the time, right? So we got delayed a little bit in the beginning, but we were able to make it up. Right, so it's good.
I think you should just wait for a second or so for people from track 2 to come back here.
Okay, sure, Ravi. Yeah.
Probably the SAE can run the short video on the standards.
Yeah, meanwhile, Dr. Ravi, there is one general question in the chat window.
Sure.
Would these PPTs, the presentations or videos would be shared with everyone?
So Yes, I think what we'll do is we'll keep these videos basically on our website. Okay. And also some of the speakers have shared it. We will just check with them and then we'll make them available.
Okay. Yeah.
Okay, we are seeing Sripati on the line.
People from track 2, I think they started joining here.
SAE has an enormous value for the aerospace and mobility industry. It is actually recognized as a global hallmark for safety, quality, and interoperability. And we, as a regulator, we actually use SAE standards in the form of our European technical standard orders and also as acceptable means of compliance to the certification standards. And people are quite surprised when I tell them that there are approximately 1,800 standards that are being used for the development of a modern airliner.
SAE is definitely a leader in providing standards, and the value of SAE is that it's recognized and used for the validation and verification of the requirements for certification and also for product assurance.
Relevance. And I say that because that is the thing that we strive for when we make standards, is to make them relevant, to make them useful to the next generation. And we've seen that over time. Ever since that first aerospace standard that I think there was how many millimeters the gap ought to be on a spark plug in an aircraft engine 100 years ago this year. So it's always things that are relevant to the future, relevant to designing the future aircraft and operating them.
As member of a standards committee, you actually can follow the leading edge of technology, and you know already today what the standards of tomorrow will be. And you actually also have the opportunity to form an excellent network across the world with the leading experts in their fields, and you make good friends.
So I think that probably one benefit of SAE is to connect people. So it's providing information, connecting the people, and also get maybe sometimes knowledge from other experts.
Satish and Sripati, you can go ahead.
Yeah, so hopefully I think participants from other track are here.
That is closed. Yeah, you can start.
Okay, wonderful. Wonderful. So Sripati, so welcome back to
Yes,
track
Satish.
1. So overall, you know, I have a feeling like knowledge is actually overflowing from my mind this evening, right? Back to back,
Yeah.
you know, nicely packed sessions. Really liked, you know, all the 4 talks in track 1. How do you see in track 2? How was it?
Track 2 is, I think highly, it was action oriented. We had a lot of questions coming in, active discussions going on, and some of the members would like to join the committees. So it is a very interactive sessions which went on, Satish, there.
Wonderful, wonderful. Maybe one thing I think that we could do is, for the benefit of participants in the other track, right? Maybe we can share some highlights of that of the respective talks in the tracks, right?
Yep. So I think
yeah,
would you like to start, or shall we start with session
please,
2?
Please go ahead, Sripati. Let's start with track 2.
So in track 2, we had the track started with Richard Embryo's session. That is basically on E40 evolution, and basically, I think main part which was mentioned, which is very, very important, is close to about 43 new publications are out from E40 members, and about 11 related to safety and certification, about 15 related to system and aircraft design and operations, and about 17 technical standards are published. This is something which is very encouraging for the enthusiasts to really look at standards as the way forward. And followed by his session, we had Bill Scofield talk about very interesting topic of counterfeit parts. That is basically everybody jumped in, and few of them asked, how do you find out that it's a counterfeit part, and how there is a what do you call it as any countering for that. So during his session, it was covered that close to about 30 plus documents either are developed or in the developing mode to counter the counterfeit parts. That is something which was insight from him. And we had Ian Haley. He spoke about the ASICs, which is about actuation, control, and fluid power systems. I think controls is one of the major. I would say it is one of the building blocks to the entire system to really operate. And we had informative session from him. And to conclude with, we had Dr. Andreas presenting on SAE G35. Basically on machine learning, AI, digital twin, simulation, all this new age and the futuristic solutions, and of course standardization for which is being built. This is something which bring in a lot of discussions from the team within session 2. I think these are the presentations and a short overview. I think it was very jam-packed, but very interesting. And I also felt that the time was very less for everybody to digest. But I think this is the beginning of each of these things to be introduced, Satish.
That's right.
On session 1.
Wonderful, wonderful. Great to hear, Sripati. So looking into track 1 session, right? So we had 4 talks, right? We started with Ronda talking about Integrated Vehicle Health Management Committee, and Ronda gave nice, overview of providing systemic view of the documentary, right? So what are all the different documents? What are all various things that are connected to this particular standard, and how these documents are related to this standard, right? And how these things are going to impact. So that's the major outcome there. And in the second talk from Dr. Ravi about electronic transactions for Aerospace Committee. So Dr. Ravi talked about complexity of data and handling of data and data across the span of life cycle, right? And Dr. Ravi highlighted about the need of collaboration at various levels in the ecosystem, right? And various standards that are addressing the different areas. So those are some of things highlighted in Dr. Ravi's talk. And then we had a third talk from Christopher Sandberg on cyber physical systems. So some new learnings here, especially from my perspective, I'm kind of like illiterate in this area, so I could gather a lot of learnings here. So Mr. Sundberg talked about this standard is being contributed by various industries, not only aerospace, ground vehicles, IT, health, right? So he talked about that stuff and gave a couple of examples of threats in the software. And it's interesting to know that hardware is even not exceptional from these threats, and it's vulnerable to threats. And Mr. Sundberg highlighted 16 domains of consideration, like asset security, application security, the ones that we talk day in, day out, in our jobs. And he also talked about mapping the process with system V-cycle. So it's kind of like punchline in Mr. Sundberg's talk is safety and security are inseparable, right? Yes. And then in the fourth talk by Mark Roboff, this is about AI in aviation. So Mark talked about gap analysis with existing standards and why this standard is important, and also highlighted the areas like data assurance and especially how to verify and validate AI models, right? And he also walked us through MLDL. For a change in this case, it's not deep learning, it's a development life cycle. So machine learning development life cycle. And one interesting aspect Mark brought out was how to certify pilots in the new age of AI, right? So these are some of the highlights, Shripati, in session 1.
Excellent.
Right.
And I think we had both the sessions which kind of converged at the same time, and all the attendees are here. I think with this, Satish, we can conclude the day 1. We thank everyone, all the speakers, all the attendees, and the backstage, the SAE office team for this wonderful arrangements. With that, see you tomorrow on day 2 for another set of excellent presentations and discussion. Thank you all.
Thanks everyone.
Dr. Ravi, you're muted.
No. Thank you.
Thank you all.
Thank you.